GeeksforGeeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with Geeks4Geeks. Geeks4Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with Geeks4Geeks. Geeks4Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with Geeks4Geeks.
Hello everyone, good morning everyone. This is Puneet Kansal from GeeksforGeeks. In today's session, we will cover the algorithm in its entirety actually. So this will be a marathon session and we will start from very beginning in the algorithm and finding the time complexity of different codes. You will be able to solve many questions, okay? And we will go till the dynamic programming. So in one session itself, we will try to cover each and everything, okay? So this session will be very helpful for if you are beginner, then still you will get benefited from this session because it's not like that, okay, I will tell you the information, then we will solve the gate question here itself, okay? So if you are a beginner, don't need to worry. I will give you the information to solve the questions. And if you are advanced learner, means you are already preparing for the gate exam, then still this is beneficial for you, this session. Why? Because we will be covering the gate questions, many gate questions we are going to solve, okay? These are not my questions. I will be taking the gate question itself and we will solve those questions itself. So both type of students will get benefit, who are beginner and who are advanced learner as well. Okay, okay, fine. So let me share my screen. Just give me a minute. Okay, please give me a confirmation that okay, if the screen is visible or not, and I'm properly audible or not. Okay, let me come back here and check out the comments. Please confirm me, okay, I'm properly audible to you people. Okay, thanks Swamsi and thanks Nitish for confirming. Okay, let me check out in my mobile also so that I can take your comments and let me go to the PPT back. Fine, so give me just one more minute so that I can connect with you people and I can take your all the questions. Okay, so just give me a minute. I will try that. Okay, this session will be useful for you people. You will enjoy. One thing is confirmed. That will be really beneficial for you because we have very limited time with us, and in this limited time, I don't want to just make. I don't want to make like that. Okay, you do not understand the things. You should understand the things. I will make sure this thing, even though you are beginner, but I will also make sure that you if you are already preparing, you don't feel bored, okay? And this session really help you for solving the question in real exam, okay? And you will enjoy, believe me, you will get benefited in the gate exam, okay? And if you get benefited, then come back to this video and then give a like at least, okay? Okay, fine. So let's start with this session. Okay, before studying, starting the algorithm, can you tell me, okay, why you are studying this? Let's start from very basic. Why you are studying it? Don't worry, we will cover each and everything. Why we are studying? Okay, whatever your opinion. Okay, what is the benefit of studying this subject? One thing is that, okay, we are studying it for our gate preparation. Yes, you people are right. We are studying it for our gate preparation. Almost 8 to 10 marks paper come from the algorithm. Almost 8 to 10 marks paper coming from algorithm, okay, every year. I'm not talking about right now programming and data structure. That is okay, considered as a different subject. Okay, you can say that, okay, algorithm plus programming data structure together are actually DSA, data structure and algorithm, which is approximately 18 marks paper come from here. Okay, but if you talk about algorithm, on average 8 marks paper come, and the PDS average 10 marks paper come. So on average I'm talking about 18 marks paper come from DSA. DSA is one of the main subject of computer science. This is the subject which is actually making you different from other engineers actually. Even if you will see that, okay, even mechanical engineers, electrical engineers, electronics engineers, they are also studying different languages, C, C++, Java. Even they are learning machine learning also. Okay, but if we will ask them, okay, are they studying this subject in their curriculum? Okay, maybe in first year the colleges have introduced C, C++ in their curriculum, but they cannot introduce this subject. Okay, this is the subject which is making the difference. Okay, this, so what the difference means, what's the benefit of studying this subject? 3 hours, Yashu, 3 hours this will be class, and we will try to cover each and everything from algorithm. Okay, calm down. Okay, let's start from very easy way. Okay, so any idea, okay, why you are studying this subject? What is the skill you are getting? What is the skill you will get? Why they are giving you 8 marks? Why these people are giving you 8 marks? Which skill you need to learn? Every company, product based company, I'm talking about not service based company, product based companies which are giving 20 plus packages, they are asking about this only. They are asking about, okay, in totality they are asking about DSA. Which skill they are looking for? Why they are paying 20 lakh to you people? Why they are paying this much amount for fresher? Why they are paying this? What the skill you will get from this subject? Anybody? Please write in the comment section. Please write in the comment section. So in this session, okay, one more thing we will follow. One rule that I will use, okay, here. We need to participate. Okay, we need to answer the questions. We need to, even we don't know the answer, we need to reply. Okay, this need to be sure. Even we don't know the answer, we need to reply. What is the benefit? Benefit is that if you are replying, then learning will happen immediately. Learning will happen even you are replying wrong answer. One thing is confirmed, learning will happen. Okay, so Rishika says that, okay, optimization of complex problems. Okay, so okay, near about you are right. So algorithms are actually used for solving the problem in efficient manner. Solving the problem in efficient manner. Okay, we are solving the problem in efficient manner. Efficient manners means like which take less time and less space. Okay, and in these two also we are not that much bothered about let's space complexity, because our RAM is increasing at very fast pace as compared to our processor speed is increasing. Okay, so we are more bothered about the time complexity. Okay, so more focus will be in this class will be on time complexity and using different techniques to solve different problems efficiently. Okay, efficiently. Okay, so these people actually looking for the people who can solve the problem efficiently. They don't they cannot take the risk Okay, like if Google cannot take the risk that okay, you are developing a web page for them, and that and user is taking lots of time to get open it. Okay, so they cannot take this type of risk. They want mm, as efficient code as possible. Okay, so that's why they are paying the good amount to you. Okay, so this skill we are going to learn from this subject. So even you are preparing for the companies directly, still you will be get benefited from this class. Okay, okay, fine. So let's start with the definition of the algorithm. Very basic. Here is one definition. Okay, definition means, I just write one or two definition here. Definition of something means you are putting some important properties of that thing inside one or two lines. So I just try to put important property of algorithm in one or two line. Okay, so like this is one definition of algorithm. An algorithm is a set of instructions which may take some input and produce the required output. Okay, so this is the one definition. Okay, I take this definition from the Corman book. Corman is the Bible of algorithm. Okay, that book you can search over the internet. Another book, if you want to refer the book, another book is the uh, algorithm data structure and algorithm made easy by uh, actually that is I forget the name. So you can search over the internet. Okay, data structure and algorithm made easy. Okay, you can write this name and you will find a book which is written by IIT Bombay alumni, and that is also very nice book. Another book is this Corman book. Okay, fine. So this is the another definition. An algorithm is a combination of unambiguous instructions which take finite steps to solve a problem in finite amount of time. Okay, just here in this definition, I just underline some of the important properties of the algorithm actually. So like one property is this. So let me write it. Another property is about the output. Another property is about the unambiguous instructions. Another property is about the finite steps. And another property is about the amount of time taken. So just definition you can make yourself also. I write two definition which have the important properties of the algorithm. Okay, so okay, let's start with the first property. You people please reply. Okay, this will make this session more interesting. You please keep replying. Okay, uh, you people please keep replying. I will take Nitish. I will take lots of questions. Don't worry. Yeah, don't worry. We will cover lots of questions. Do not need to worry. Okay, so here also itself you will find out many question itself. Okay, don't worry. So first question, if you want to solve. Okay, first question, can you tell me, is the input is compulsory or not? For an algorithm, input is compulsory or not? Don't worry, I will give you so many questions, I will ruin your life. Don't worry, I have lots of questions with me. Don't worry. So first question, okay, just tell me, input is compulsory or not? Please reply in the chat box. So in this session you need to reply. You need to reply. If you will reply, you will enjoy this session. If you will not reply, then after some time you will feel that okay, you will feel like you are something like happening here in Tamil language. Okay, you will not able to understand the things. So keep replying, keep connected, just keep replying. Okay, wrong or right will not matter. So please reply, everybody please reply. Input is compulsory or not? Okay, let me write. Input for an algorithm is compulsory or not? Input is compulsory. Compulsory or not? Please reply. Yes or no? Just whatever is coming to your mind, reply. If you have written an algorithm, you have written a code, is the input is compulsory or not? You just reply. You don't need to worry about it at all. Okay. You just reply. So people are saying yes, input is compulsory. See, in the definition itself that is written may. I have written may over here. I have written may over here. Input is not compulsory. This is not compulsory to have an input for an algorithm. Okay, maybe, okay, let me write one code over here. I'm writing one code. Okay, so I'm printing something. Okay, you do not need to worry if you don't know. Although for the gate exam, C language is compulsory, but still okay. I'm writing, or you can take it as a pseudo code. Okay, I'm printing. Okay, hello. I'm printing hello over here. Okay. So can you tell me, is there any input? Another question again. Please keep replying. That will be the mantra of our this session. You need to keep replying. Either wrong or right doesn't matter at all. Okay. So can you tell me, is this code, is this algorithm have any input or not? Yes or no? Input or not? Is this code having some input or not? Yes or no? Keep replying. Yes or no? This code is having some input or not? Yes or no? Anshul says no. Anshul, is there anyone who's saying yes? Gate CSCS parents say no. Everybody is saying no. And actually, you people are right. You people are right. This code don't have any input. But one of the student asked me, sir, but you are printing hello. Is this hello is not the input? Is this hello is not the input? You are printing it. This hello is not the input. Note down. Input is always given by the user, not by the programmer. This hello is written by the programmer. Okay, this is hard coded. This is hard coded. So this is not an input. Okay, this is not an input. Input is always given by the user, not by the programmer. Okay, and this is written by the programmer. This is hard coded by the programmer. Okay, so input is not compulsory. Input is not compulsory. There may be input, there may not be input. Okay, fine. Another question. Output. Please keep replying. Output is compulsory or not? Output is compulsory or not? Yes or no? Please reply. Compulsory or not? Yes or no? Please reply. Yes or no? Keep replying. Output is compulsory or not? See, output is compulsory. Output is compulsory. See, if you hear one, Ishika is saying that no, output is not compulsory. Okay, tell me. If you are developing a software, somebody asks you, can you please write a software for me? I don't want any output. Do you find any user like this who's saying that, okay, I don't want any output. You please write the software for me, but I don't want any output. There is no use of that. Okay, that thing. Okay, that is the part of the algorithm now. What the benefit if you are writing a code and you don't have any output? Output is compulsory. Output is compulsory. Otherwise, what is the benefit of writing that code itself? Okay, output is compulsory. Input may or may not be there. Input may not. Maybe you want to process some data and you want to store that in the in your hard disk somewhere. Okay, output is also doesn't mean that you are printing something. Output is doesn't mean that you just printing something. Output can be like you are processing the data. That is also one output you are getting. You are processing the data. That processed data you are means maybe storing in database or somewhere. Okay, so that is also output. Output doesn't mean that you're just going to print something. Okay, so output is compulsory. Okay, another property of the algorithm is instructions should be unambiguous. Instructions should be unambiguous. Okay, let me ask another question from you people about the unambiguous instructions. Okay, about the unambiguous instruction, let me ask one question. So I'm writing a code over here about the unambiguous instruction. You please tell me what is the output over. Okay. Can you tell me what is the value of C over here? Can you tell me what is the value of C over here? What is the value of C? Just a minute. Okay, I want to update it. Just a minute. I want to update it. Let me write like this: A equal to 5.4, B equal to 2.1. Can you tell me, okay, what is the value of C over here? What is the value of C over here? Whatever is coming to your mind. It's a pseudocode. Okay, it's a pseudocode. I write a pseudocode. We are talking in the term of pseudocode. Algorithms are not language specific. This is another property, one another property of algorithm. Algorithms are not language specific. Okay, they are not language specific. So a value is this, B value is this, and C value is, what will be the C value? Can you tell me? Vashmi is saying 7.5, aspirant is saying gate, CSC aspirant is saying 7. Anshul Dhakkad is saying error. And gate aspirant was earlier saying that C is not declared. Okay. So actually the value of C, some people are saying okay, like 7.5, and some people are saying 7. Actually, the value of C depend upon its data type. The value of C depend upon its data type. Like if C is float, if C is float, then that will be 7.5. The value of C will be 7.5. And C is integer. If C is integer, the value of C will be 7. So actually here the value of C will depend upon its data type. That is depending upon its data type. This statement I can say is ambiguous. This statement is ambiguous for the compiler. This statement is ambiguous for the compiler. Compiler don't know what is C. We need to tell to the compiler, okay, this is an integer or float. Otherwise there can be multiple values. There can be multiple values. The instruction should be unambiguous. This instruction is ambiguous. This instruction is ambiguous. Ambiguous means which have many meanings. Which have many meanings. Compiler understand only one meaning of one thing. It's a machine. We need to tell, okay, this is the specific meaning of this thing. Okay, so compiler have only one meaning of one thing. Okay, no, only one meaning of one thing. So instruction should be ambiguous, not unambiguous. This is ambiguous instruction. Okay, instruction should be unambiguous. So we need to tell either this is float or this is integer. Okay, fine. One more thing. Okay, one last two properties: finite number of steps and finite number of time. Okay, let me write a code over here and you people tell me how much time this code will take. How much time this code will take. Integer a, let's suppose, is equal to 5, and while a is less than 10. Okay, let me print something. Let me print. So don't need to worry about the syntax and all. Okay, so it's like a pseudocode. Okay, printf, like but we can print anything, means again. Okay, hi. So can you tell me how much what is the time complexity of this algorithm? 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 Please keep replying. If you really want to make this session interesting, we are not here for giving the right answers. But if you really want to make one session very important for the final exams, then you need to reply. You need to reply for that. Please reply. Doesn't matter at all you are giving wrong answer, right answer. If we know everything, then we don't need to be here itself. Okay, then we don't need to be here. If we know our everything, so it's okay if we are giving the wrong answers. It's okay. Okay, but important is that we keep replying. Okay, so some people are saying infinite, some people are saying constant. Constant might means they are writing like 5, or that is actually constant only. Okay, so actually, first of all, this is not an algorithm. The moment I ask you what is the time complexity of this algorithm, you have to ask me, sir, according to your definition, according to your definition, according to the definition of this algorithm, this is not an algorithm, because algorithm always take finite amount of time to execute. Algorithms always take finite amount of time to execute. This code is taking infinite time to execute, because this loop is executing infinite amount of time. This loop is executing infinite amount of time. There is, I have not incremented a value inside the while loop here. Okay, so first of all, this is not an algorithm, because this is not satisfying our definition itself, algorithm definition itself, which is saying that every algorithm take finite amount of time to execute. Okay, and okay, yes, I can call it as a program. I can call it as a program. Okay, program can take infinite time to execute. Program can take infinite time to execute. This is a difference also between program and algorithm. Okay, if somebody asks you what is the difference, program can take infinite time to execute. Like you have written, maybe you have written many codes in your labs, and you might have stuck in infinite loops over there. Those are programs. Okay, but in algorithms, we we algorithms always take finite amount of time to execute. Programs may take infinite time to execute. Okay, okay, one last question from here, then we will move on. Last question: how many steps this code is taking? How many steps this code is taking? Okay, how many steps this code is taking? This the same code, number of steps. So okay, let me write the some number of here. One, this is the first line, this is the second line, this is the third line of code, this is the fourth line of code, this is the fifth line of code, this printf statement is sixth line of code, this is seventh, and this is eighth line of code. Okay. So can you please tell me how many steps, how many steps this code is taking to execute? How many steps? How many steps? So get aspirant is saying infinite steps. And what about these numbers, these statements? Is this not the number of steps I'm taking? Is this not like eight? Am I not taking eight number of steps to execute? No, I'm not taking eight number of steps. So just I want to tell you one thing is that now, first thing you are right, gate as parent. This is taking infinite steps to execute. Okay, and this is another. This is again violating the definition of algorithm. That okay, algorithm always take finite steps to execute. This loop is taking infinite steps to execute. Okay, and then what these numbers are? These line of codes are. This is so line of code, this is line of code is here is 8, is not same as number of steps taken. Number of steps taken, both are different things. Line of code is different from the number of steps taken. Line of code is totally different from the line of code is different from the number of steps taken by the algorithm to execute. Okay, okay, so let me clear all this stuff. And okay, one last question from here so that we can move to the time complexity questions itself. Okay, one last question. Let's suppose I have given you 10 line of code. 10 line of code I provide you. I write a code of 10 line. Can you tell me how much time that will take? What will be the time complexity? What will be the time complexity of that code? I just provide you one information that okay, you have 10 line of code. Okay, maybe I can ask it this in different way also. This is a 10 line of code, and this is okay. This is okay, maybe 1000 line of code. Line of code. Okay, this is another code of 1000 line. This is a code of 10 line, 10 line of code. Okay, so this is you can say program 1 and program 2. Can you tell me which will take more time to execute? Can you tell me which will take more time to execute? Can you tell me? Can you tell me out of program 1 and program 2, which will take more time to execute? Keep replying, whatever is coming to your mind. Okay, just keep replying. Let's make this session interesting. Okay, otherwise I will start sleeping over here. Okay, and when I will start sleeping, you will also start sleeping. Then both will sleep. All internet will go sleep then. So it's better we keep replying. Let's keep the system alive. Right or wrong doesn't matter at all. That actually should not matter in class. That should not matter in class. That should matter, but in exam. In exam, that should matter, not in class. Please keep replying. Doesn't matter right or wrong. Which program will take more time to execute? One program have only 10 lines in it, another program have 1000 line in it. Which program 1 or program 2, which will take more time to execute? Which will take more time to execute? Actually, I cannot predict. Actually, I cannot predict. Just by looking at line of code, I cannot say program 2 will take more time to execute. Maybe program 1 can take more time to execute, that have only 10 lines in it. Maybe I have a code like this which is executing, maybe I don't know, 1 million time. This loop is executing 1 million time. Okay, I am printing hello again and again. I'm gonna mad to print hello 1 million time. I'm printing hello. I'm asking to, I'm saying hello to you 1 million time. Okay, this is only 1, 2, 3, 4 line of code, 4 line of code. And there can be another code which is of 1000 line of code that do not have any loop. No loop is there. No loop is there in this 1000 line of code. Okay, then this will take only 1000 steps to execute, which is constant. So just by looking at line of code, I cannot say what is the time complexity of that algorithm. Okay, because there might be a loop inside here and there might not be any loop inside this code. Okay, so line of code do not decide the time complexity. So what decide the time complexity? What decide the time complexity? Time complexity is decided by the loops in the program. Okay, that is decided by the loops in the program. Okay, let's move on now. And before moving on, let me give you more information, little bit about the let me move this upside, about the, okay, what is the gate weightage from last 10 to 11 years, so that we just get some insights. Like in 2023 there was 6 marks paper from algorithm, 6 here, and 2021 10 marks paper, 6, 7, 7, 8, 9, 7, 10, 10. So okay, on average we can say that 8 marks paper, 7 to 8 marks paper is coming from the algorithm. Okay, on average, from if we look at these statistics from 10 to 11 years. Okay, and 8 marks is very important. Okay, very important. You cannot leave at least a DSA. We cannot leave DSA. You should not leave any subject, but DSA is one of the most important subject for you people. Fine. Okay, again, little more information about the syllabus of this subject, like this time and space complexity, finding time and space complexity. 1 marks paper comes from here. On average, I'm talking about on average. Searching, sorting, and hashing 2 marks. Greedy techniques 2 marks on average. Dynamic programming 1 to 2 marks. Divide and conquer 1 to 2 marks, and graph like minimum spanning tree and all, like Astra Bellman for 2 marks paper. So this is the topic wise. Okay, how many marks paper is coming on average? Okay, every year. Okay, so little bit insight. Okay, little bit insight. Okay, little bit about the space complexity now. So space complexity is nothing, just the input space plus auxiliary space taken by an algorithm. Total is known as space complexity of that algorithm. Space complexity, that's it. So what is input space? For example, input space, for example, you want, you give me some numbers. Okay, you give me n numbers to sort. You give me n numbers to for sorting. Okay, you say that please sort these n numbers in increasing order. You give me this in an array of n size. Okay, so this is the input space. So the space required to store the input, this is the, you give me n numbers as an input for sorting. Okay, so you give me these numbers in an array, so this array is taking n space to store these number. So this is the input space required, which is used for storing the input. Another space is the auxiliary space to process this data. To process this data means to sort this number. If I'm using some extra space, if I'm using some extra space, for example, in the case of merge sort, in the case of merge sort, we use again extra space of order of n. Okay, so extra array is taken by the merge sort to sort the numbers. So if I'm taking extra space, I just want to say, if we are taking extra space to sort the numbers, then that space is known as the auxiliary space. That's it. To perform that particular task, to perform that particular task on the input, if we require extra space, that is auxiliary space. So total space is known as the space complexity of that algorithm. That's it. Space complexity of that algorithm. Fine, fine. Now let's talk about the time complexity. Okay, you please keep replying me what is the time complexity of different codes. Okay, so here let me give you one code. Okay, let me write a code here. So don't need to worry about the syntax. Okay, don't need to worry about the syntax. Can you tell me, okay, how much, what is the time complexity of this code? Please keep replying now. Keep replying, what is the time complexity of this code? What is the time complexity of this code? If any doubt is coming, immediately ask. Immediately write in the chat box. That is also important. So, okay. So the time complexity, yes, get aspirant, this is order of 1. This is order of 1. This is taking constant time to execute. Okay, let me give you one definition of time complexity. So that definition can be applied to any algorithm. You take any code from the Google, you pick any code, you can find the time complexity of that code using this definition. One definition. Okay, let me write the definition, and we will use this definition again and again. So let me write over downside here. So the definition of what do you mean by time complexity? If you are finding a time complexity, you can find with this statement. What is that? Okay. Okay, let me write. Finding the time complexity of an algorithm means finding that part of the algorithm, which is taking maximum time. That's it. You can apply this definition over any code. So let's see what this definition is saying. So finding the time complexity of an algorithm, what do you mean by this? Finding, if somebody asks us, okay, what is the time complexity of any algorithm, then that means finding that part of the algorithm which is taking maximum time. Okay, we need to just find out which part of the code is taking maximum time. So can you people tell me which part, if I provide you a code, then which part of the code take the maximum time? Which part of the code take the maximum time? you have some line of code with you. Then in this line of code, which part of the code take maximum time? Which part of the code take maximum time? Can you please reply in the chat box? Can you please reply in the chat box? Which part of the code take the maximum time? Can you please reply in the chat box? Loop. One is loop. There is one another thing also. It's not only the loop. Yes, you are right. Loops are those part of the code which take the maximum time. Okay. All other statements are executing one time only. Okay. This you can see here. This loop is executing 10 times. This loop is executing 10 times. This is executing one time, one time, one time. This loop is executing 10 times. Okay, fine. Any other thing than the loop which is taking maximum time in the code? Any other thing than the loop? Yeah, loop is right. One is loop. Any other thing? Anybody, please keep replying. Any other thing? And what is that here? This statement will execute one time. Okay. So the second thing, okay, let me tell you. The second thing is the recursion. Is the recursion. If there is a loop in the code, that will take more time to execute. Out of this complete code, this part will take maximum time. Okay. And second thing that can consume maximum time is that can happen due to recursion. That can happen due to recursion. So if you are finding the time complexity of any algorithm of any code, you need to find out these two things in the code. How much time you are consuming in that loop, how much time you are consuming in the recursion. That's it. We need to find out these two things. In this code, we can see that we don't have recursion actually. We have loop here. So this loop is taking how much time? This loop is taking 10 steps to execute. So I can say that, okay, this loop is taking 10 steps to execute. I can say that the time taken by this code is order of 10. Is order of 10. And 10 is what? 10 is a constant. 10 is a constant. And we can put this into, we can represent it with 1. So constant is represented with 1. Okay, so we say that, okay, the time complexity of this code is order of 1. Okay, fine. Let me a little bit more modify this code, and you people please tell me what is the time complexity again. Let me modify it. So for this code, the time complexity is order of 1, because this, we are just looking at the loop, and this loop is executing 10 times only, and 10 is a constant. Okay, so we say that, okay, the time complexity of this code or algorithm is constant. Okay, but let me replace this 10 with maybe, okay, 1 lakh. With 1 lakh I replace with this 10 with 1 lakh. Can you tell me what is the time complexity? Can you tell me still what is the time complexity of this code? What is the time complexity of this code now? Yes, still this is, yes, great aspirant, this is still constant. Even though this loop is executing 1 lakh time now, this loop is executing 1 lakh time, but still this is a constant. This is a constant only. This is a constant only. The loop is executing only fixed amount of time. I can say that order of 1 lakh I can write, or I can say that, okay, this is executing fixed amount of time. So I will say again, this is a constant. Okay, so let me replace this 1 lakh with some other number. Maybe let me add some zero here, more zero. Let me add more. I can maybe I can fill this complete screen also with all these zeros. So can you tell me right now what is the time complexity of this code? I'm writing 0. 1 after 1 I'm writing lots of 0. Lots of 0. Lots of 0. So Vinod says that still this is constant. Still this is constant because this is fixed. This is fixed. You are executing fixed amount of time. You are executing fixed amount of time this loop. Okay, one of the student asked me in one of the class that, okay sir, how you are saying that, okay, this code is with so many this big number. This is also, you're saying this is taking constant time. And earlier when the loop were executing only 10 times, again you were saying that the time complexity is constant. You're saying both algorithms are same in term of time complexity. How you can say like that? How you can say okay, this and this are having the same time complexity? Definitely they have different time complexity. Actually, this thing is standardized by the software industry. This is not standardized by me. This is standardized by the software industry. What they are saying that if your code is taking fixed amount of time, then we don't bother at all. Actually, we will consider the time only consumed by the customer. We don't want to make wait to our customer. Okay, before customer come, if you are taking lots of time to execute your code, we are not bothered about that. How much to your time? Maybe you are taking okay 10 hours to execute your code. We are not bothered. But once customer make the query, immediately he must get the answer. So immediately he must get this hello must be printed. So one time we will execute this code, whoever customer is coming, whoever user is coming, that can watch this hello immediately. Okay, that do not need to wait, because that is not giving any input here. Customer user is not giving any input over here. Okay, so that's why software industry is not bothered. That is considering the time, that only, which is, that is the waiting time of the user they are considering. And if some constant amount of time we are executing the code, then user do not need to wait for that. User only wait only for the code in which that give the input, for example, in place of this 10 or 1 lakh or the big number, if I'm writing over here, n, now this n, let's suppose I'm taking from the input scanf. If let's suppose I'm taking this n as an input from the user, now user give the input and now he want to see the output. Okay, so now the how much time this loop is executed, that much time user need to wait, actually. Okay, so now the time complexity of this code will be order of n. You know this thing, that time complexity of this code will be order of n. Okay, because now user need to wait n time. N value is decided by the user, how much time he need to wait. N value can be 10, can be 1000, 1 lakh, but that is variable. That is a variable, so we put a variable over here. Okay, so this loop is executing order of n time, fine. So let me go through different type of complexities and then we will take the questions. Let me go faster a little bit. So we have taken the start now. So let's go, we can move a little faster now. Okay, so you people keep telling me, okay, keep replying in the chat box. So this, I hope you understand, this loop is taking order of n time to execute. Now I'm modifying a little bit this code. So I'm writing one more loop inside this. Can you tell me what is the time complexity of this code? Can you please reply? What is the time complexity of this code? Keep replying, please. What is the time complexity of this code? Yeah, that is n square. One answer I will get, I will keep moving on. So the outer loop is executing n time, inner loop is executing n time. So for one value of this is executing n time. So for n value, this will be n into n. If loop is inside loop, then that will be multiplied, simple. So this will be order of n square. Okay, let me modify again. So rather than this now, let me make modification over here. Rather than incrementing with 1, let's suppose I'm incrementing with 2, j plus 2. So earlier that was j equal to j plus 1. Now that is j equal to j plus 2. How much time this code will take to execute? Please reply. How much time this code will take to execute? Please reply. That is important. Right or wrong doesn't matter at all. Right or wrong doesn't matter. Please keep replying. Please reply. How much time this will take? We replace j with j plus 2. Anybody? Do anybody can answer? You can ask the questions also. If any doubt is coming, please ask immediately. And if otherwise answer, reply, just reply. Wrong or right, we are not here to give the right answers. Just reply whatever is coming to your mind. So you are saying gate aspirant is saying same answer. Yeah, that is same. Actually, this loop, internal loop will execute n by 2 times, half times. That will execute n by 2 times. Okay, this will execute n times. That will be n into n by 2. That will be again order of n square. So 2 we can remove. 2 is a constant. We can remove the constants. We can remove the constants. Okay. Okay. Let me do little more modification in this. Let me modify this part. Can you tell me what about this? If I'm replacing this with I equal to I divided by 2. So what is the output? If I divide the I with I divided by 2, every time I'm making the I, sorry, here I am not dividing, I'm multiplying. Because I'm starting from 0, so we need to go to n, so we need to increment. So I equal to I into 2. So I equal to I into 2. What is the time complexity? Yes, that is log n. That is log n. So whenever you're multiplying, you're starting from 0, you're going to n. Whenever you are multiplying, the complexity will be log n. Okay. Do you want mathematical proof or we can move on? If one thing, this is a thumb of rule you can take, that okay, whenever you see multiply, the complexity will be in the form of log n. Okay, maybe I can write another code also, like another loop, maybe over here. So I'm replacing this loop with another loop. So this loop is starting from n and going up to that is still greater than 0, and now I'm dividing this I with 2. Okay, then the complexity of this code will be again log n. Okay, so you're starting from n going up to 0, dividing every time with 2, the complexity will be log n. So the thumb rule you can take right now here is that whenever you're dividing or whenever you are multiplying, the complexity will be in the form of log n. The complexity will be in the form of log n. This is the thumb rule right now you can take. Okay. I'm not, if you want me, okay, to go in mathematical detail, I can go over there also. But if right now, maybe you can take, if you are multiplying and dividing, then the complexity will be in log n. If you're multiplying with 3, then what will be the time complexity? That will be log n base 3. That's it. If you're multiplying with 300, then the complexity will be log n base 300. Okay, that's it. Okay, last one complexity, and then we will move to the questions. Last one more type. One more type. Okay. So let's suppose I'm writing here I equal to I square. What will be the time complexity? I equal to I square. Anybody? Last one. After that, we will move to the questions. Gate questions directly. Anybody can reply if so. Okay, otherwise let me that will be actually log of log n. That will be log of log n. Okay, let me give you thumb rule. So right now take the thumb rules. Thumb rule is like that: if you are square, if you are making in the power, if you are making the power of something, okay, then the complexity will be incrementing in the power, then the complexity will be in the form of log n. And when this is for the this loop, when you are starting from 0 and going up to n, you are at the down stair, you are going up to n, okay, and you are incrementing with powering by making power, then that is log of log n. Let me replace this loop with another loop also. I equal to starting from the n, starting from the n and going up to 0, downside we are going. This time we are, what we are taking, okay, root of I. We are taking root of I. Every time we are making root of I, root of I, root of I, then again the complexity will be log of log n. The complexity will be log of log n. In these two cases, the complexity will be log of log n. And when you are multiplying and divide, the complexity in the form of log n. Okay, the complexity will be in the form of log n. That's it you need to know. Okay, fine. Okay, so we are ready. Okay, now for gate questions. So let's solve some of the gate question and ISRO based questions. So please keep replying. Keep replying, keep trying, keep replying. Right or wrong doesn't matter at all. You just reply. Meanwhile, you are trying this. Let me tell you one thing. How you can score good in gate exam. How we can score, okay, maybe below 100 rank in gate exam. Below 100 rank in gate exam. Keep trying this thing. Okay. The people might be, you can listen this thing also. This is important. How you can get below 100 rank in gate exam. So let me give you a thumb rule. Again, thumb rule. How you can get below 100 rank in gate exam. Uh, Actually, let me share some data with you. I have some data with me from last 10 years. From last 10 years, how the students are behaving, how they are behaving in the gate exam. I'm just sharing the data. From the data, you will get the insight how you can get below 100 rank in gate exam. So actually, approximately, if we'll check out in the CS branch, near about 1 lakh students, more than even 1 lakh 10,000 near about. Last year, 1 lakh 8,000 students appear for the gate CS only. Okay, so 1 lakh students are appearing every year approximately in the gate exam, CS gate exam. And do you know that uh, only 10,000, only 10,000 are passing the gate exam. 90,000 are not passing the gate exam. They are failing the gate exam. Okay. Do you know who are these 90,000 students who are not passing the gate exam? These are the students. I'm just sharing the data. This is not my own opinion. I'm just sharing the last 10-year data. Okay. These 90,000 students who are every year this is happening actually. These 90,000 students are those students who are not covering the syllabus, who are not covering the gate syllabus. Gate means they are not, I don't know if they have taken some course, they are not consuming the complete videos, or they are, if they have not taken the course, there are many people who have not taken the course in this also. They are not studying means either from books or any resource. Okay, they are not covering the complete syllabus. They are not going through the complete syllabus of the gate. Okay, these are the 90,000 students which are failing the gate exam. Okay, out of these 10,000 students, okay, who are the students who are getting below 1000 rank? Who are the students who are getting below 1000 rank? These are the students actually who are covering last 10 to 20 years PYQs. I can assure you one thing. If somebody will ask me, sir, I want to get below 1000 rank only. Can you tell me one line? Can you tell me what I need to do? I will say that just solve the last 10 to 20 year PYQ. One thing is sure, out of these 10,000 students, 9,000 students have not solved the PYQs. These people have not solved the PYQs, 9,000. They clear the gate exam, they cover the complete syllabus, but they do not solve the PYQs, the previous year question. They do not solve the previous year questions. These many people are not solving. Okay. And the one who are solving, they're getting below 1000 rank. I can give you surety. I'm online here. You can catch me. You can write anything over here. Okay. Yes, only 10,000 qualify gate aspirant. Every year this is happening. Okay. So if you want below 1000 rank, then you need to solve the PYQs. There is no other way. Let me tell you the truth. Another thing, okay, out of these 10, if you are saying, sir, can you tell me how I can get below 300 rank? How I can get below 300 rank? To get the below 300 rank, these are the people. Who are these people who are getting to below 300 rank? These are actually taking test series. They are giving test series. I'm not saying particular one test series. Geeks or Geeks is also providing the test series. Okay, I can promote right now. So Geeks or Geeks is also providing the test series. They are taking the test series. And even let me tell you, I'm just sharing the data right now. They are not taking one test series. They are taking more than one. They are taking two test series, three test series from different places. That they're giving the test series. And they're working on that. Okay, they're finding their weak section and improving over that. So this also helped them to manage their time in the gate exam. They used to the gate exam also. They're giving full mock test. I have seen the people who get good rank, actually they share with me that okay, we give 50 plus mock tests. 50 plus mock tests they have given. Okay, I'm just sharing the data with you people. So if you want to get below 300 rank, test series you need to give. So one thing is sure, 700 people who get below 1000 rank do not go for the test series. They don't went for the test series. Okay, somebody is asking me, sir, who are the people who are getting below 100 rank? These are the people who are working on their silly mistakes. Silly mistakes. They are working on their silly mistakes. They are giving the test series. They're finding out where they are making the silly mistakes, means like little mathematical calculation mistakes they are making in some type of questions. They're marking those questions in PYQ also, in test series also. They're going through those questions again. They are working on those silly mistakes. They're finding sometimes they are not able to understand the question. One type of questions they are not able to understand. They're marking those questions. They are going to those questions again. Okay, and when they're going them again and again, then they able to overcome those silly mistakes. Even uh, sometimes they share that like that, sir, we make the same mistake again in exam. We work over that, still we make the same mistake, and that is the problem. Their rank vary from 1 to 100. the, these people, I believe, they have same caliber. They have put the same hard work. Just that was the at that moment of time they make the same silly mistakes. That's why their rank vary. Otherwise they have same caliber, although the people who are getting below 100 rank, they are going to get means ISC, IIT Bombay, IIT Madras. This remains the main target of these people. Okay, and they get their favorite college. So I just tell you one thing. Okay, I don't have time with me. I just want to tell you. Okay, is that it's not, there is no magic is happening behind the scene. One thing is that, and everything is very pretty much clear. Some people believe that okay, nothing is clear, everything is clear. If you are not covering the syllabus, you're not going to pass the gate exam. If you are not covering the PYQs, you're not going to get the below 1000 rank. If you're not, third step, if you're not covering the test series, you're not going to get below 300 rank. Everything is pretty much clear. If you want below 100 rank, you need to work on your silly mistakes also. Everything is pretty much clear. Everything is pretty much clear. Okay. Okay. So this was the okay little bit idea. Actually, what is happening in every year from last 10 years I'm watching. I just share the data with you people so that you get the insights and you can set your targets. But okay, let's come back to this session itself. And can you please tell me what is the answer over here? Please reply. So in this session also we will cover okay, lots of gate questions. Fine. What is the output? Output, one output at least I'm expecting. Anyone, please reply. Please keep replying. Wrong or right doesn't matter. Yes, B is the, let's see, okay. Gate aspirant says that B is the output. Please, everybody, please reply. Make this session more interesting. If you will reply, the session will be more interesting. If I will be keep speaking alone, then the session will go boring actually. Okay. Okay, let's see how he's saying B. B is the right answer. Yes. Actually, the loop is executing 5 times. Yes. I value is 10. I is declared outside also, inside also. But every time when we will print the value, we will take the local value. We will take the local value. So this 10 will be printed every time. Okay, we are not going to print this I. This I. We will print this I. Okay. Fine. So this will be printed actually. Fine. What about this gate 2017 question? Please keep trying. That is important. That is important. Keep trying, please. Yeah, Sneha, that is B. Yes, please keep trying. Keep replying. That is the most important part. This is the mantra. Mantra for our today's session. Keep trying and keep replying. Okay, this is important. Just a minute. Just a minute. Okay, so we get. I hope I'm audible. Am I audible? C for Chennai. So people are replying C over here. Hmm. So let me check out. Is this right or wrong? I hope I'm properly audible now. So keep reply. Please confirm me if I'm properly audible or not. Hmm. The solution is given by, the explanation is also given. Okay, fine. C is the right answer. So let's see what is the question. Here is a code. We need to find that complexity. Okay, and let's see. There is an outer loop which is executing n time. Fine. This inner loop is actually depending upon n I value, depending upon I value. So let's see how many times this inner loop is executing, already given by the gate aspirant. He is saying that first time this inner loop will execute how many times? Actually n times, because initially the I value will be 1. So every time I will increment with 1 1 1 1, and this loop will execute n time then, because every time we are incrementing with 1. Okay, and the second time now I value will be 2 here. The I value will be 2, then we will increment with 2 every time. So if we are incrementing j equal to j plus 2, then internal loop will execute n by 2 times. Okay, next time the I value will be 3. So this condition will change with j equal to j plus 3. So this loop will execute with this condition n by 3 times, and so on n by 4 up to n by n time, we can say. Okay, so here n we can take as a common, that will be 1 plus 1 by 2 plus 1 by 3, 1 by 4, and so on. Okay, 1 by 1 we can say. Okay, and sorry, 1 by sorry, at 1 by n, that will be 1 by n. Okay, so this series is actually, if you will sum up this series, okay, this is if you will sum up this series, you can check out, this will be equal to log n. This is one of the famous series, actually harmonic series, and if you will sum up it, then you will find out, okay, the complexity is of this is giving, this will be equal to log n. Okay, and n into log n is n log n, n into log n is n log n, so the time complexity is n log n. That is, yes, C is the right answer. Okay, fine. Check out this one, gate 2015. Gate 2015, please try this one. Keep trying, keep replying. This is going to our mantra. Keep trying, keep replying, please. I will keep sharing some important points about the gates in between, so that keep us active also. Okay, we will keep solving the questions, and I will keep sharing my experience, uh, how you can improve in different things, and you can ask the questions also if you are facing some particular problem, so that we can make the session more interesting also. Yes, Saurabh, the answer is given by gate aspirate itself. We are every time in that question, we were every time initializing the I value with 10 again. Again, we were making it 10. And that was the local value actually. So that was the concept of local and outer value. Keep trying, keep replying over here. Let me also check out something here. This loop is executing n time, and this loop is executing, we know that divide, thumb rule says that whenever divide looks, we check out divide, the loop is executing log n time. Whenever multiply is there, again the loop is executing log n time. Okay, let's take the thumb rules and let's try to solve these questions. Keep trying, please keep replying, that is important. That is the mantra for today. If any problem you are facing in your preparation, you can write that also. We will keep discussing that also, so that we can make our session interesting from that point of view also. Okay, I will keep sharing that thing. Okay, we get one or two answer from here. D, you are giving the right answer, and let's check out, is the D is right or wrong. Yeah, D is the right answer. Yes, D is right answer. How D is right? Let's check out how the gate aspirant is coming with D as the right answer. This loop is executing n time, fine. P value is 0, fine. So after executing this loop, We are incrementing p value with 1 only every time here. Okay, every time with 1 we are incrementing p value. So after executing this loop, which is executing log n time, the p value will be log n. The p value will be log n because we are incrementing 1 every time. 1 plus 1 plus 1 plus how many times? Log n time. So how many will be the value p of p value? Log n only. And this loop is executing p time. P value is log n only. Okay, so 1 to p we are going, but with which speed? Log n speed, means with in log n time we are going there. So what will be the value of q now? How many q will be incremented? So this loop is going up to log n, and we are going with log n speed. Okay, so this loop will execute log n time, and upper limit is also log n. So the value of q will be log of log n. That will be log of log. If we are, if I'm or I can say that, okay, this the value will be log of p. Log of p, how much value is the p? Okay, and p value is log n, so the value of q will be log of log n. Okay, they're asking us what will be the q value. What will be the return q value? The q value will be, see, for one time we execute this loop, the q value is log of log n, and this loop is executing n time. So n time we will incrementing this value again and again. So for one time the value of q is log of log n. One time we execute this outer loop. Okay, and if we are executing it n time, that will be n into log of log n. Okay, so yes, that's why D is the right answer. I hope you get the answer. If any doubt, please don't hesitate to ask. Please ask the doubt. Please ask the doubt if any doubt is coming to your mind. That is very important. Like Saurabh have already cleared one doubt. That's great. Can you solve this question? I have already tell you solving the PYQ if you want below 1000 rank. If you want below 1000 rank, no other option. PYQ you need to solve. Last 10 to 20 years PYQ you need to solve. So let's solve it together itself here and understand the concepts also. Okay, from these PYQs. No other option. Because this is already happening from last 10 years. How we can change the trends? Please try. Keep trying, keep replying. Okay, let me write this pseudo code in the form of a code. Okay, uh, readable code. So this is the if statement. If n is less than equal to 2, then we are returning 1. Okay, and else it's the same code, I'm just writing in more readable format. Else return this thing. We are returning this thing. Okay, and actually this is in this function procedure an. This code is here. This function is recursively called here. This function is recursively we are calling. Okay, and every time we are passing root value, we are reducing the n value with root. Every time we are reducing the value with root, and we know that we have already discussed that whenever we see the root value, we are decreasing the n value by taking the root of it. Okay, square root of that we are taking again and again. We are calling this function. Next time again, that will be square root again until unless that will not reach to less than 2. Okay, so how many times this will keep calling recursively? That will be whenever you see root, you can say that will be log of log n. That will be log of log n. So C is the right answer. Yes, C is the right answer. I'm not going in very mathematical detail right now because we don't have time. Okay, if you will take the GFG courses, then you will find out over there that okay, everything is all this. Why this is going to be log of log n? You will find out the explanation over there. Okay, But right now, okay, you can take the thumb rule that whenever you see the root, if you're reducing the value with taking the root, the complexity will be in the form of log of log n. Whenever you see multiply and divide, the complexity will be in the form of log n. Okay, fine. Check out this one. ISRO 2011. Keep trying, keep replying, please. Right or wrong doesn't matter at all. Please reply. Please try. One answer I get, I will also start solving at my end. Let me share one more truth with you people. I will keep sharing this throughout my session. I cannot keep it with me. And this is now my problem also. I'm a mentor. I need to share the things. Okay, I cannot stop myself now. It's already more than 10 years I'm sharing the stuff. Even you will stop me, sir, please don't share, I will share. Okay, so we one answer we get from gate aspirant, that is 7. Let's check out if that is right or wrong. The answer is B. Check out again, gate aspirant. Anybody is getting B? Anybody is getting B? Check out. Okay, let me try otherwise at my end. So initially x value is 1 and I value is 1. Okay, and until unless x value is less than 500, we will keep executing this loop. Fine. So the x value here is 2 power x. Okay, we updated. Finally, we need to return what is the value of I. Okay, so let's see. Initially, the x value I value is 1 when x value is 1. Then the x value is 2 power 1. Let's do it. And I value will be 2. We are incrementing with 1 only. Fine. This condition still 2 is less than equal to 500. We can go inside the loop. Now the x value will be again, that will be 2 power 2. Okay, and I value will be 3 incremented with 1. Still this 2 power 2 is less than 500. Fine. So we can go inside the loop. We can update the x value. So x value is 2 power this, whatever we have right now, 2 power x actually, 2 power 4. 2 power 2 is 4, and I value will be 1 increment 4. Fine, this is still 2 power 4 is still less than 500. So we can go inside and we can update this value. So 2 power 4 is 16. So we make it to the power 16. I value is right now is 5. Okay, and this is 2 power 16 is actually is not smaller than 500. That is greater than 500. 2 power 16 is greater than 500. We will come out of the loop. What is the last I value we get? 5. Last I value is 5. That's it. So 5 is the right answer. Yes, yes, aspirant, you are right. If you are making mistakes, that's nice. You are learning. That is showing that you are learning actually. If you are making mistakes, you must have seen the ad, दाग अच्छे हैं. तो अगर mistakes हो रही हैं तो that means we are learning. I don't know why in the education system. Uh, let me speak little bit about the education system also. Our education system is very bad according to me. That is very bad. Means we are not allowed to make the mistakes. We are always need to give the right answer. Learning always is the combination of both of these two things. We always learn by making mistakes only. I don't know why we only focus on getting the results. We need in education system we need to improve a lot here in India. Okay, I will keep talking about this stuff. I have collected so many things in last 10 years. Okay, so the answer is 2 power n. Let's see. Yes, you are right. The answer for this is 2 power n. This function is recursively calling. This function is recursively calling two times. Okay, okay. Let me. This problem I can solve in two ways. One way, okay, let me tell you. By making the recurrence relation. By making the recurrence relation. So whenever somebody give you the recursive code means in which we have recursive function. Here recursion we are using. We are calling the same function from inside. So recursion is there. So whenever recursion is there, then if you want to find the time complexity, then we can create a recurrence relation of that code. How to create the recurrence relation? Very easy. So simply write this function as a tn. Just write the function name. Let's suppose function name is recursion. Here I write t in place of that, and input value, the n is the input size. Okay, after that, here there will be some recursive functions. These are two recursive functions we have. So again I'm writing the same function name t. In place of recursive I write t. Okay, and now the input size is n minus 1. Here also t n minus 1. Okay, and check out the what is the rest code is doing. How much time the rest code is taking. This code is taking constant time to execute. There is no loop inside here. There is no function here. This code will execute one time only. This will take constant time. So we can write the recurrence relation now very easily. What? Write tn equal to this recursive terms you write. Let me write the recursive terms. Tn minus 1 plus tn minus 1. And how much time the rest of the code is taking? The time taken by rest of the code is 1 here. Okay, so I can write tn equal to 2t n minus 1 plus 1. That's it. This is the recurrence relation. And if you will solve this recurrence relation, then you will find out that the complexity is coming is 2 power n. The complexity is coming is 2 power n. You can check out on Google also this recurrence relation. This is one method which how you can find out the time complexity of recursive code. First convert it into the recurrence relation, and then you can solve that recurrence relation. There are various methods also, like iterative method, substitution method, recursive tree method, master method. Okay, so there are various methods to solve the recurrence relations. Right now, okay, let me share one method with you, which is another way to solve this problem intuitively little bit. Okay, so this is a one method. Just convert into the recurrence relation and solve the recurrence relation. You will get the answer. Fine. Let me share another method. So which is actually recursive tree method I will use. So how this will be solved? So initially the input size is n. Okay, and when you call the two functions, the input size was n minus 1 and n minus 1. Again you will call these function recursively. Every time you are decrementing with 1, so that will be n minus 2 and n minus 2. Here also n minus 2 and n minus 2. You will keep calling like this. Okay, n minus 3, n minus 3, and so on up until unless you will get n value as 1. You will get n value as 1. So this will be a big tree. Okay, and after making this recursive tree, this is known as recursive tree. After making this recursive tree, now you can find out, okay, how much time you are taking. First thing you can see here is that how many functions call you have made. These are all functions call. One function call, another function call, another one, so on. Okay, how many functions call are there? So this is a complete binary tree. This is a complete binary tree. Okay, in a complete binary tree, how many nodes are there? Number of nodes in complete binary tree will be order of will be 2 power n. That will be 2 power n nodes will be there in a complete binary tree, and every function is how time taken by every function is how much constant. Every function is taking constant time to execute. Okay, so I can write the time complexity of this code. Let me write the function name is number of functions call number of function calls into time taken by each function. Time taken by each function. So number of functions call are 2 power n, and time taken by each function call is constant. So that's it. That is order of 2 power n. Okay, fine. Yes, approximately same gate aspirant. Approximate, not exactly same, but approximately same. Tower of Hanoi is having the that will also make the almost complete tree. This is making a complete tree, complete binary tree. Almost complete binary tree is different little bit, and complete binary tree is different. Right now, I don't want to confuse you right now. Okay, but yes, they are. Uh, the complexity will be same. Yes. Okay, let's try next question. Can you please try this one? 2008. If let me tell you one more thing. If I will try, that will not benefit you. Let me tell you. You will find out the better solutions on Google itself. If you want the answer only, then that is already available on the internet. If I will try, that will not benefit you. Believe me. If you will try, you're not getting answer, it's okay. No problem at all. If you are not getting answer, no problem at all. Learning will happen. Nobody can stop the learning if you will try. Please keep trying. Keep replying, keep trying. Please. Keep trying, keep replying. So this is almost same code as the previous one. Just we one thing we make some two multiplication, extra multiplications. And here we have n minus 2 rather than n minus 1. This will actually create the almost complete binary tree. Okay, and again, this part is taking constant time to execute, and some more constant operations are going on, like multiply and this plus. These are all constant. Calling this function, how many functions will be there? Again, approximately 2 power n functions will be there. Approximately, I'm talking about. Okay, and so the time complexity for this will be again that will be 2 power n. So fn will be 2 power n. Fn will be 2 power n. What about this code? So if you will check out, if you will see it carefully, you can check out maybe later also. There is a, we need to find out the loop only. Okay, this statement will execute one time, one time, one time. Don't need to bother about them. How many times this loop is executing? So this loop is executing, you can see n time. The n value, I value is incrementing one by one only. And nothing is, we are not changing I value. I don't know whatever is happening inside. Let it keep happen. Whatever is happening inside, let it keep happen. We are only bothered about how many times this loop is executing. Excuse me. So we are not bothered whatever this stuff he's doing. Let him keep doing this. We are bothered about how many times this loop is executing n time. That's it. F2 is executing n time. So let's see which is the right answer. F1 and F2. F1 is 2 power n, okay, and F2 is n. So yes, B is the right answer. B is the right answer. Check out this one. Keep trying. Keep trying, keep replying. Yes, Pupender, B is the right answer. And you know already, yes, compiler is also here now in the fight. Okay, so which is the right answer? Let's see. Don't matter at all what is the right answer. but let's see. Okay, you people are trying, that's great. D is the right answer here, because if you see, we have already solved this problem. We are recursively calling this function, and here we are, every time we are taking root of n, we are reducing the n value by taking root. And whenever you see root, decreasing the n value by root, then that means the code, this recursion will execute log n time, log of log n time. Okay, so D is the right answer. Whenever you see the root, okay, or uh, in the power, if you see the value, okay, then that will be log n. Okay, fine. Okay, that's it for the time complexity. We have solved many questions from the time complexity. We get the idea of different type of time complexity: linear, logarithmic, we exponential also. We have seen the recursive uh, questions also. Okay, so we have gone through that, but still you need to practice at home. Okay, let's move to the next topic, that is asymptotic notations. Let me give you the idea about asymptotic notation, and after one slide you will be able to solve each question from asymptotic notation, because I will not left anything over here. Okay, and if you will be knowing everything, then no question will be left, only from one slide, this slide. Okay, fine. But this is the definition. I always start from the definition so that nobody can say that I don't know this thing. So okay, asymptotic notations are just nothing, just they are just mathematical way to represent algorithm complexity. Okay, so this is just symbols. These are just symbols, like this big O, this octopus type symbol, big omega, this theta, small o, this uh, little omega symbol. So these symbols have some meanings, okay, and they have some meaning. We just need to know that meaning, that's it. We not need to know that meaning. If we know what they are saying to us, whenever I write one particular symbol, what that mean is, if we know this thing, that's it. We need to know, or we can answer, that's it. We can answer each and every question. I will give you the gate questions right now. After this you will be able to solve, because you know the meaning, that's it. Okay, so let's see what are the meaning of these. What are the mathematical meaning of these notations? Okay, fine. So first of all, what is big O notation? So we have five different notations which represent the time complexity or space complexity. Okay, that can be represented for both. These notations can be used to represent complexity, either space or time. Okay, fine. Let's start with the big O notation. So okay, if somebody, let me tell you, let me write one algorithm. I write one algorithm, and that complexity is n square, big O of n square. If somebody write this algorithm one, and he say that, sir, my algorithm one complexity is big O of n square. He give me this statement. He give me this statement. Then what I will understand? What I will understand from this statement is, he is telling me, that, sir, give any input to my algorithm one. You please give any input. Any input means you give, let's suppose this algorithm is for sorting the numbers, let's suppose. Okay. And he is saying that, sir, give the number in increasing order. Okay. Like give the number in decreasing order. Okay, what you can do, you can shuffle the numbers in any way. You just give the input in any way. My algorithm will maximum, will take n square time. He is saying this thing to me if he is making this statement, if he is using big O notation. So big O notation is telling us maximum time taken by an algorithm. That is telling us maximum time taken by the algorithm. So let me write some keyword here: maximum time taken. Okay, maximum time taken. Or you can say that this is showing the upper bound. This is showing the upper bound, maximum time taken by an algorithm. Give any type of input, the algorithm one will not take more than n square time. That's it. That's it. One more thing you need to know about big O. Okay. Bigo also have this property. Okay, I'm directly telling you, I'm not going in the proof. You do not need to go in the proof also to solve the asymptotic notations questions. And what is that thing you need to know? Left hand side is less than equal to right hand side. what this is. So if I'm writing like this, see here you can see that algorithm 1, I can replace this big O with the less than equal to sign. Less than equal to sign, I can replace this big O notation. Okay, so I can write like this also, this statement. Algorithm 1 is less than equal to n square. Okay, I can replace this big O with this less than equal to. Okay, how this is coming, don't need to worry. Okay, just take this point. And this is very true. According to our what I speak verbally also, I say that my algorithm 1 will take either less time or equal time to n square. That will not take more than n square time. This statement is also saying the same thing. You can logically understand means, but you don't need to cram. Algorithm 1 will take either less time or equal time the n square. This is what big O notation says. This is what big O notation says. That's it you need to know. You can solve all the gate questions from big O notation. Okay, let's talk about big omega. Big omega is telling about the minimum time. Minimum time taken by an algorithm, or you can say the lower bound, that is showing us the lower bound of an algorithm. Minimum time taken by an algorithm. So if somebody telling me this thing, sir, I have written an algorithm 2 and the complexity is big O of n square, then what I will understand from this statement? I will understand that he is telling me, he is saying me that, sir, give any input. You please give any input. You give the number in increasing, decreasing, shuffle it in any way. Minimum, minimum time taken by my algorithm is n square. That will not take less than n square time. Minimum time taken by algorithm 2 will be n square. Note down one thing. I don't know about the maximum time taken. Here in this statement, I don't know what is the maximum time taken by its algorithm. Here in big O notation, I don't know what is the minimum time taken by algorithm 1. I don't know. He don't tell me this thing. He don't tell me about the minimum time taken in big O notation. He don't tell me what is the maximum time taken in the big omega notation. What they are telling? They are just telling me one thing. Big O notation is telling one thing. What is the maximum time taken? That is not telling me what is the minimum time taken. That is just telling what is the maximum time taken by algorithm 1. And big omega is telling what is the minimum time taken by the algorithm 2. Okay, minimum. Fine. I don't know about the maximum. One more thing that is also telling me left hand side will be either greater than equal to right hand side. Okay, we will use this thing to solve the gate question. So I can replace this statement with algorithm 2 is greater than equal to. So I just replace this big omega with greater than equal to algorithm, n square. So this statement is also the meaning same. My algorithm is I either will take more time or equal to n square. That will not take less than n square. That can be maximum equal to n square. Either that will take more than n square. Okay, so that will not take less than n square. Minimum time taken by my algorithm 2 is n square. Yes, that is means meaningful. Fine. Theta notation, people usually make the mistake. I don't have time to, I'm not asking right now. So I can speak in Hindi also if you people are comfortable. Anybody not comfortable in Hindi? Anybody not comfortable in Hindi? Anybody not comfortable in Hindi? Let me know. So otherwise I can mix. Okay, Bhupender is asking for speaking in Hindi also, mixing Hindi English. If you feel that okay, yeah, that is right. Okay, fine. Then if anybody is not comfortable in Hindi, then can let me know. If anybody is there, then I will speak in English only. Otherwise, okay, let me come in Hindi also. Theta notation. Okay, in theta notation, usually people make the mistake. Whenever I ask what is theta notation, what is theta notation? Okay, can you reply? What theta notation tell us? Can you reply? What theta notation tell us? Please reply whatever is coming to your mind. ओके, बिग नोटेशन तो हमें अपने को बता रही है मैक्सिमम टाइम क्या लग रहा है अपने को, बिग ओमेगा बता रहा है मिनिमम टाइम क्या लग रहा है, थीटा नोटेशन क्या बता रहा है? That is the mistake, Pupender. That is the mistake. Usually, many people make means. I seen many students make this the same mistake. They call it average. They call it average time taken. No, that is wrong. That is wrong. Theta notation do not show the average case complexity. Theta notation do not shows the average case complexity. That shows that when when maximum time taken and minimum time taken is same, when an algorithm is taking, let's suppose there is an algorithm 3 that is taking this much maximum time, and the same algorithm is taking minimum time is also n square, then rather than writing these two statements, I can write one statement. What? Algorithm 3 is taking theta of n square time. जब मैक्सिमम टाइम और मिनिमम टाइम दोनों सेम हो, ओके, देन वी कैन यूज द थीटा नोटेशन. सिंपल. It's not the average case. It's not the average case. Okay. Okay. Fine. So, okay, here I can write that left hand side is equal to right hand side. Or I can write when upper bound is equal to lower bound, then we can use the theta notation. Fine. Small omega, so small omega is just related to the big O notation. Big O notation, in big O notation what we were doing, लेफ्ट हैंड साइड इज लेस देन इक्वल टू राइट हैंड साइड, और यहां पे क्या करेंगे, सिंपल, लेफ्ट हैंड साइड इज स्ट्रिक्टली लेस देन राइट हैंड साइड. लेफ्ट हैंड साइड इज स्ट्रिक्टली लेस देन राइट हैंड साइड. बस इतना ही डिफरेंस है. ओके, स्मॉल ओमेगा इज समवट रिलेटेड टू बिग ओ नोटेशन, बिग ओमेगा नोटेशन. यहां पे क्या है, यहां पे क्या था, लेफ्ट हैंड साइड इज ग्रेटर देन इक्वल टू राइट हैंड साइड, पर यहां पे क्या रहेगा, लेफ्ट हैंड साइड स्ट्रिक्टली ग्रेटर देन राइट हैंड साइड. बस इतना आ जाएगा. This is the only thing you need to know. You can solve all the questions. Okay, so let's jump to the questions now. Yes, we are going to solve the gate questions. Some practice questions are also here. Okay, can you answer this question first? Can you tell me which one is true and which one is false? So let me write for you people. Big O notations tell us left hand side is less than equal to right hand side. Please write true and false. Big omega tell us left hand side is greater than equal to right hand side. Theta we use when left hand side is equal to right hand side. Small o we use when right hand side is strictly greater than left hand side. Small omega when left hand side is strictly greater than right hand side. That's it, you need to know. So please reply, everybody, please reply. True, false, true, false. So first one, Bhupender says that 1, 2 and 4 are true. Okay, let's see. So this is true. Let's see. Left hand side is smaller than equal to right hand side. Yes. This is big O notation. Yes. This is true. Both are equal. Equal can also be represented with big O and big omega. Not only with theta, but with these two also. Yes, I can use. This is true. This is false. Left hand side cannot be greater than right hand side. Left hand side is smaller than maximum that can be equal to right hand side. This is false. Here we can remove the constant. Okay, remove the constant, then see. So right hand side is greater than left hand side. Yes, this is true. Here left hand side is greater than right hand side. This is also true. Yes, this is also true. Fine. Can you try these? If any doubt, you can ask me. Otherwise, try these next questions. Please keep trying, keep replying. That is important. Keep trying, keep replying. Wrong or right doesn't matter in class. That should not matter in class. Please keep trying, keep replying. Yes, compiler, you are right. Please keep compiling. Keep compiling the questions. Keep trying. In your while your preparation, let me tell you one thing. There will be one stage when you will be preparing for the gate exam. There will be one stage that you will feel that you have covered the complete syllabus. You've applied the gate questions also, but you are not feeling confident. You are not feeling confident. It will be feeling like, okay, some like not, you are not feeling progress. That stage will also, you might, will definitely will come. There will be one thing in your mind that, okay, at least you will, this happens almost with everyone, like I want to give up right now. I cannot take it anymore. And uh, that is the, I will say that, okay, the point, which is deciding who is going to get the rank, who still keep moving, keep moving, keep moving, who still keep moving after that point. Those are the people who are getting below 100 and below 300 ranks. Don't give up, keep doing it. Fine, okay, we get TF from compiler. So let's see. This is true. Yes, this is true because omega is also supporting that equal. Okay, fine. And what about this one? This is not true. Left hand side should be greater. Here, right hand side is greater. So this is false. Remove the constant. Equal is fine. True. This should be equal. Theta should be equal. No other option. Here this is not. This is false. Theta should be equal. Fine. Try next five questions. Please keep trying. Please keep trying. Why I'm covering all this stuff? Because I'm just telling you, after this asymptotic notation, what I have already tell you, if you will go back and if you will try the question, you will be able to try almost all the questions. Okay, because we have covered everything. They cannot ask out of the syllabus. They can ask from the concepts only, and we have covered that. That's it. Just when I'm making sure that you understand the things. Keep trying, keep replying, please. Keep trying, keep replying. That is our mantra. Compiler says that TFT. Let's see. This is true, yes, because both are equal. They should be equal. Theta notation should be equal. No other option. Constant, let me remove. They are not equal. They are not functionally equal. Okay, so this is false. Small o, right hand side should be strictly greater. Yeah, this is functionally greater. This is true. They cannot be equal in small o notation. This is false. This is true because n cube is greater, strictly greater than n square. Last five questions. Please try last five questions. We will move to the gate questions then. Last five questions and we will move to the gate questions then. This is making sure that you know these five notations. If you are able to answer these 20 questions, means you understand what are these notations. If you understand, you can solve the questions. Keep trying, keep replying, please. Keep trying, keep replying, please. Okay, gate aspirant says that 1 and 20, 20th one is false. 16, 17, 19 is true. Let's see. So let me remove the constant. They cannot be equal. In smaller, that should be right hand side should be greater than left hand side. Here, left hand side is greater than right hand side. Yes, true. They cannot be equal. False. They cannot be equal. The left hand side is greater. Fine. True. They cannot be equal. Functionally, we are talking. Remove the constant and then check out. This is also false. Yes. Fine. So we have now done enough practice. It's okay. We have done enough practice now, and we are ready to solve the gate questions. So let's check out whether we have learned properly or not. So this is gate 2023 question itself. This year question. Oh, no, no, no. Last year question. This is 2024 now. Okay. Please try this one and reply. Keep replying, please. Let fg be a function of natural numbers given by, we have two functions with us, this and this. Which statement, what is the relation between them? So first statement is true or not? Yes, first statement is true. Right hand side is greater. Second statement is false because that is strictly greater actually. Third statement is also true. Even third statement is more true. Third statement is much better even than the first statement. Although first statement is also true. Last statement is false. They are not equal. N and n square is not equal. This is n. This is n square. A and C should be the right answer. Yes. A and C. Anshul, you are right. Let's try next one. Gate 212. Keep trying. Keep trying. Keep replying. So two functions are given. One is a worst case, one is average case. So A is for average, W for worst. Which statement is true? We know that average case can be equal to also worst case, but these two condition can happen actually. That's it. And if you remember, these two condition belong to big O notation. Okay, so C should be the right answer because worst case can be take more time than the average case, or that they both can be equal. For example, in the case of merge sort, average case is n log n. Here is also n log n. But in the case of quick sort, this is n log n and this is n square. Okay, so yes, C is the right answer, which is always true. Yes, this will be always true. You give me any function, you give me any algorithm, this condition will always be true. So they use the word always. That's why we need to pick C. That's why we need to pick C. Otherwise, this can also be the answer. This can also be the answer. Otherwise, B and C, you can also say that, sir, why not B and D? Why not B and D? Because Average case can also be equal to worst case, and maybe this can also happen. But because they were used the always word, that's why C is the right answer, because that is covering both the cases. Fine. Gate 2007. Keep trying. Okay. Okay, to you people first try. B for Bihar. So this loop is executing root n time, square root n time. Okay. So don't get confused with that. Okay, I said you that, okay, if whenever you see the root n, the complexity will be log of log n. Okay, so whenever, if you are using the root n here, if we are changing the I value here, incrementing with 1 every time, not with root n we are decrementing it. Okay, when we are decrementing the I value with root n every time, then the complexity will be log of log n. But right now in this code, we are just simply incrementing the I value with 1 and going up to root n, going up to root n. So this loop will go up to root n. We are finding actually the number is prime or not. So what can be the worst case and best case in this case? So the best case can be the number is not prime itself. Okay, maybe, okay, let me take 7. So when, if n is 7, then when we will come inside, and when we will divide 7 with 2, then oh sorry, if number is prime, uh, number is not prime means like 8. Let's suppose we take 8. So if we are taking 8, okay, 8 mod 2 is satisfied. Okay, so this number is not prime, this number is not prime. Okay, so this can be divisible by other than any number except then itself and 1. Okay, so this is not prime. So if the number is not prime, then this loop will execute, we will return from here, and this code will execute constant time if number is not prime. But if number is prime, then this loop will execute up to root n time. This loop will execute up to root n time. Okay, so actually this is the efficient code. This is the efficient code for finding the number is prime or not. Okay, and the worst case complexity of this is root of n, and the best case is 1. Okay, so yes, B is the right answer. Yes, Pupendra, B is the right answer. Any doubt you can ask me in this? Any doubt you can ask me? Otherwise I will, you can ask me any doubt from anywhere. Okay, from any slide. Actually from any, you can ask any question. If you have any specific question also, you can ask that also. Try this one, ISRO 2020. Keep trying, please. Geeks for At Geeks for Geeks, actually the students we need the students who can continuously work, who means can work for long hours. If you can work for long hours, we can in the classes we can discuss the topic, we will solve the questions, we will discuss the topic, you people will solve the questions. Actually here right now I'm giving little less time also, maybe if you are, for starter point of view, if you have already done, then you will be finding little easy. If you are not done, then you will must be finding difficult. But in our classroom programs, we we cover topic wise topic, and we leave the student at below 1000. How? Just solving all the pyq in the class itself. Okay, and you people solve that, and after that they need to just practice through the practice questions. Okay, so the important part is that you cover the topic. You cover the topic from anywhere. What you people can do is you just cover the topic. Okay, cover the topic, and if after covering the topic you are able to solve the gate question, then that uh, from wherever you are studying, that material is very good. Okay, just I'm telling you one thing, means from where you have to study. Learn from the anywhere, from YouTube, anywhere, from any book or any course. If you are not able to solve the gate questions, please drop that course. If you are not able to solve the questions after taking some course, if you are not able to solve, these are the questions we need to solve in the actual exam. And if if somebody is providing the course and you are not able to solve that question which we need to solve, then that course is, I'm telling you, there is no use of that course. You are wasting your time. You're wasting your time. So always take the lecture of those, or study from that place which give you confidence that okay, now you can solve the gate questions. Only take those courses. Okay, from YouTube also. Fine. The right answer you people are saying C. Let's me check out. Yeah, C is the right answer. Let me check out how you are coming with C. So I value 1 going to n. So multiply. The moment you see multiply, put it log n. Here is 2, तो बेस में हम यहाँ पे 2 रख सकते हैं, ठीक है. और इंटरनल लूप यहाँ पर ये कहाँ पे, ये n तक जा रही है, सिंपल. ओके, तो कितना टाइम लग रहा है, कितना सम की वैल्यू कितनी होगी, सम की वैल्यू कितनी होगी, n log n, दैट्स इट. मल्टीप्लाई, जब लूप के अंदर लूप है तो मल्टीप्लाई कर दो बस. एन log n into n, that is n log n. So which is not the, this is one of the silly mistake people make. This not is bold by me, that will not happen in exam. Okay, they, what they will see, the moment they might see, which is, they don't check out the statement properly. The moment they see the a, they may, okay, A is the right answer. Yes, A is the right answer. Actually, A is the right answer, because I can write it as a big O of n square, because big O saying that left hand side is less than equal to right hand side. Yes, n square is greater than n log n. और इसको मैं ऐसा भी बोल सकता हूं, अगर मेरा कोड n log n टाइम ले रहा है, तो वो, अगर वो इससे कम टाइम ले रहा है, तो वो इससे भी तो कम टाइम लेगा. अगर वो इससे कम टाइम ले रहा है, तो वो इससे भी तो कम टाइम ही लेगा. ओके, तो दिस विल बी, दिस स्टेटमेंट इज ट्रू, दिस इज ऑल्सो ट्रू. ओके, दिस इज ऑल्सो ट्रू. एन इंटू log n इंटू log n, तो ये जो है ना फंक्शन, ये वाला फंक्शन है ना, ये n log n से बड़ा है. तो अगर बड़ा फंक्शन मैं n क्यूब लिख दूं, यहां पर 2 पावर n लिखूं, n पावर n, all are right answer. All are right answer if I'm using big O notation. Okay, this cannot be the right answer, because this is smaller than n log n. This is smaller than n log n. Okay, so they're asking which is not the right answer. C is not the right answer. C actually right. So right now the answer is C. Fine. So let me take one question from Imran. As non-CS student, how can we know time complexity square root come log of log n multiple? Okay. इमरान, पहले तुम कैन यू अंडरस्टैंड हिंदी? सो आई एम स्पीकिंग हिंदी. ओके, पहले तो मैं आपको बता दूं, यहाँ पर नॉन सीएस और सीएस वाली कोई चीज नहीं है। नॉन सीएस वाले मैथ्स अच्छा समझते हैं सीएस वालों से। एक चीज और डालो दिमाग में, यू आर बेटर। ओके, तो या अब मैंने आपको बताया ही नहीं है, पहली बात मैंने आपको बताया ही नहीं है कि भाई ये जो हम अगर हम आई को मल्टीप्लाई करते हैं 2 से तो log एंड कॉम्प्लेक्सिटी आती कैसे है, मैंने बताया ही नहीं है आप लोगों को। जब मैंने बताया ही नहीं है तो आपको आपको पता कैसे लगेगा? ठीक है ना, राइट नाउ। अभी तो मैं सिर्फ इतना मैंने बोल के सेशन को लेके जा रहा हूं कि भाई इसकी अगर आपको मल्टीप्लाई दिखे तो आप लोगन ले लो। अगर आप सीएस के हो, नॉन सीएस के हो, तो कोई भी हो, तो मैंने थंब रूल दे दिया था। अभी तो एक थंब रूल मैं दे के चल रहा हूँ। ठीक है, मैंने बताया ही नहीं है। जब मैं बता दूंगा तो आप लोगों को कोई उस चीज में भी कोई वो नहीं रहे। ओके ठीक है, इसमें 2 मिनट और लगेंगे अपने को। ये हम ले लेते हैं। अगर मैं एक लूप ले लेता हूँ यहाँ पर, देखते हैं इसकी कॉम्प्लेक्सिटी लोगन कैसे आ रही है। बहुत ईजी है, 2 मिनट और ऐड हो जाएंगे, कोई बात नहीं। आई की वैल्यू 0 से स्टार्ट हो रही है, एन तक जा रही है। ठीक है, और हम आई को ना हर बार 2 से मल्टीप्लाई कर दे रहे हैं, 2 से मल्टीप्लाई कर दे रहे हैं। ठीक है, तो अब ये मैं बोल रहा हूँ, ये जो लूप है ना, ये log एन टाइम एग्जीक्यूट होगी। देखते हैं कैसे होगी, बहुत इजी है। देखो आई की वैल्यू स्टार्टिंग में क्या है, 1 0। ओके, एक बार हमारी लूप, हमें हमें क्या देखना है, अपने को ये देखना है हमारा को टाइम कॉम्प्लेक्सिटी का मतलब ये है ये कोड ना कितने टाइम एग्जीक्यूट हो रहा है, ये लूप कितने टाइम एग्जीक्यूट हो रही है। ठीक है, अपने को बस यही चेक करना है, ये लूप कितने टाइम एग्जीक्यूट हो रही है। तो जब आई की वैल्यू 1 थी तभी एग्जीक्यूट हुई। ठीक है, अगली बार क्या होगी? ओके, मैं यहाँ पे 1 पुट कर लेता हूँ क्योंकि यहाँ पे हम मल्टीप्लाई कर रहे हैं, तो 1 पुट कर लेता हूँ। 1 से चल रहे हैं एन तक जाएंगे। ठीक है, 1 से चल रहे हैं एन तक जाएंगे। तो पहले आई की वैल्यू 1 है, तो एक बार लूप एग्जीक्यूट हुई। अपने को बस यही देखना है कितना टाइम ये लूप एग्जीक्यूट हुई है। ठीक है, चलो देखते हैं। 1 है, एक टाइम एग्जीक्यूट हुई। अगली बार आई की वैल्यू कितनी कर दिया आपने, 2 से मल्टीप्लाई कर दिया तो 2 हो गई। एक बार और लूप एग्जीक्यूट हुई। अगली बार आई की वैल्यू कितनी होगी, फिर आपने 2 से मल्टीप्लाई कर दिया। ओके, तो कितनी होगी, 2 into 2 4। आई कैन राइट लाइक 2 power 2 ऑल्सो। एक बार और एग्जीक्यूट हो गई। आई की वैल्यू फिर कितनी होगी, अभी मेरी आई की वैल्यू 2 power 2 है। अगर आप 2 power 2 को फिर 2 से मल्टीप्लाई कर दोगे तो कितना आएगा, 2 power 3। फिर एक बार एग्जीक्यूट हुई, फिर आई की वैल्यू एक बार 2 power 4 फिर एग्जीक्यूट हुई, सो ऑन। मेरे को नहीं पता, ये जाएगी सम 2 power k तक। के मेरे को नहीं पता के क्या है, के अपने को बता रहा है नंबर ऑफ टाइम्स दिस लूप इज एग्जीक्यूटेड। तो एक बार एग्जीक्यूट हुई जब आई की वैल्यू दो दो थी तब एग्जीक्यूट हुई, या मैं 2 power 1 कर सकता हूँ सीरीज बनाने के लिए। इसको मैं 2 power 0 कर सकता हूँ थोड़ा सीरीज की फॉर्म में लेके आने के लिए, सो दैट हम ये log n निकाल पाए। ठीक है, तो 2 power 0 जब वैल्यू थी आई की तब एग्जीक्यूट किया 2 power 2 में, 2 power 3 में, 2 power 4 में, अब टू 2 power k। जब तक मेरा 2 power k n तक इक्वल नहीं हो जाता, जब वो n के इक्वल हो जाएगा, ठीक है, उसके बाद फिर मैं लूप से बाहर आ जाऊंगा। ठीक है, उसके बाद लूप से बाहर आ जाऊंगा। तो मेरे को बस देखो, ऊपर आप ये पावर नोट करोगे ना, पावर एक एक करके ही बढ़ रही है, 1 2 3 4 सो ऑन अप टू के। तो ये जो के है ना, अपने को बता रहा है कितने टाइम ये लूप एग्जीक्यूट हो रही है, कितने टाइम ये लूप एग्जीक्यूट हो रही है। यही फाइंड आउट करना है, कितना टाइम ये लूप एग्जीक्यूट हो रही है, क्योंकि वही तो टाइम कॉम्प्लेक्सिटी है हमारी, कितने टाइम ये कोड रन हो रहा है। ठीक है, तो ठीक है, ये के की वैल्यू फाइंड आउट करनी है अपने को। बस इसको उठा लो, अब इस एक्सप्रेशन को हम उठा लेते हैं, मैथमेटिकली हम सॉल्व कर रहे हैं। 2 power k = n, अपने को k की वैल्यू फाइंड आउट करनी है। k अपने को बता रहा है कितने टाइम ये लूप एग्जीक्यूट हो रही है। ठीक है, तो इसको सॉल्व करते हैं। इसको सॉल्व करने के लिए ना log ले लेते हैं दोनों साइड, log ऑफ 2 power k = log of n। ठीक है, अब एक प्रॉपर्टी होती है log की, log a पावर b जो होता है ना, वो b log a होता है। जो पावर होती है ना वो आगे आ जाती है ना, तो ठीक है, ये प्रॉपर्टी यूज करते हैं। k आगे आ जाएगा, k इंटू log 2, और इधर हमारा log n ही है। बेस में हम 2 ले लेते हैं, बेस में 2 ले लिया तो ये जो है ना, ये जो टर्म होगी ये क्या होगी, 1। log ऑफ 2 क्या होता है, 1 होता है अगर बेस 2 है। तो k हमारा आ गया इस साइड पे, k की वैल्यू कितनी होगी, log n, दैट्स इट। मिल गया अपने को k की वैल्यू। k अपने को क्या बता रहा था, कितने टाइम ये लूप एग्जीक्यूट हुई है, वही तो टाइम कॉम्प्लेक्सिटी है। तो व्हाट इज द टाइम कॉम्प्लेक्सिटी ऑफ दिस लूप, दैट इज log n, दैट इज log n। सो दिस इज द मैथमेटिकल प्रूफ, दिस इज द मैथमेटिकल प्रूफ of how if you are multiplying every time with 2, every time multiplying with 2, 2, how many times this loop will execute? This loop will execute log n time. आप कोई नंबर भी डाल के देख सकते हो इसमें, जैसे कि n की वैल्यू लेट्स सपोज मैं 64 पुट करता हूँ, ठीक है, देखो कितने टाइम एग्जीक्यूट होगा, एक बार, दो बार, 2 power 2, 2 power 3, 2 power 4, एंड 2 power 5 इज 32, 2 power 6 इज 64। ओके, तो मैं बोल सकता हूँ ओके 1 2 3 4 5 6 टाइम्स हमारी लूप एग्जीक्यूट हो रही है, और log ऑफ 64 अगर आप लोगे वो भी कितना आएगा 6। सम पीपल मे से दैट ओके वन मोर टाइम लूप विल एग्जीक्यूट, तो ठीक है वन मोर टाइम आप लगा लो, लेकिन अप्रोक्सीमेटली वो 6 टाइम ही एग्जीक्यूट हो रही है ना। तो वैल्यू वैल्यू डाल के देखोगे तब भी आप लोग से निकालोगे, देखो 6 टाइम ही एग्जीक्यूट हो रही है। तो दिस इज द मैथमेटिकल प्रूफ। ओके, you need to get 8 hours, it's not 4 hours is not going to work। okay fine। okay, I hope ये थोड़ा बहुत आइडिया आप लोगों को लगा होगा। आज मैं तो बैठ सकता हूँ, मैं तो पूरा नाइट तक बैठ सकता हूँ। आई हैव बिल्ड दिस कैपेसिटी, बट वी हैव ऑन यूट्यूब वी हैव अदर सेशंस आल्सो, other classes will also go, and that you can enjoy that classes। okay, I can give you the intuition right now here। okay fine, let's solve this question। ठीक है, जितना कर सकते हैं उतना करते हैं, आप ट्राई करते रहिए, ठीक है। प्लीज ट्राई दिस वन। आई होप Irman you get the intuition, okay, how we are getting log n। so try this one please। ये लूप तो हमारी, ये वाली लूप तो जो है ना हमारी कितना टाइम एग्जीक्यूट हो रही है 100 इंटू एन। एसिम्प्टोटिकली आप एन भी बोल सकते हो क्योंकि 100 कांस्टेंट है। ओके, आई एम नॉट गोइंग इन, I'm not going in very detail why we are removing these hundreds, what is the logic behind that, because there is no time for that also। that can happen only we have 8 hours classes। okay, then we can connect one to one point। and अभी क्या हो रहा है मैं आपको सच्चाई बता देता हूँ। देखो इन सेशंस में क्या रहता है, हम हमें भी जंप करना पड़ेगा, क्योंकि मैं सब कुछ पढ़ाने लग गया तो फिर कुछ भी नहीं हो पाएगा, और एक एक स्टेप से चलने लग गया तो, और एक एक स्टेप अगर मैं स्टेप्स छोड़ के चलता हूँ तो आप लोगों का ब्रिज टूट जाता है। बच्चे समझते हैं कि भाई वो लैग कर रहे हैं, वो समझ नहीं पा रहे हैं। सब में कैलिबर है, सब में कैलिबर है। मैंने अपने करियर में देखा है, वो सेम कॉलेज से सेम क्लास से बच्चे आ रहे हैं, एक का रैंक बिलो 100 है और एक गेट एग्जाम को पास भी नहीं कर रहा है, और एक का रैंक 5000 है। मैंने ये एग्जाम्पल देखे हैं, एक का रैंक 1000 है। सेम क्लास में बैठे हैं, सेम बेंचेस पर, सेम कॉलेज में, बता रहा हूं मैं ये एग्जाम्पल्स। एक बच्चे का 100 रैंक भी आ रहा है, तो एक बच्चा पास भी नहीं कर रहा है गेट एग्जाम में, एक का 5000 रैंक आ रहा है, एक का 1000 रैंक आ रहा है, और ये इनमें से कुछ ने हमारे साथ काम भी किया है, इसलिए मेरे को ज्यादा पता है। मैं क्या बताना चाहता हूं, ऐसा नहीं है कि भाई जो गेट क्लियर कर रहे हैं 100 रैंक वाले वो आपसे ज्यादा कैलिबर के हैं। ये आप गलत सोच रहे हो। आप सोच रहे हो जो 90,000 बच्चे जो पास नहीं कर रहे हैं गेट एग्जाम, दे हैव लो कैलिबर देन जो पास कर रहे हैं। नहीं है, ऐसा नहीं है, ऐसा नहीं है। क्योंकि अगर ऐसा होता तो वो सेम कॉलेज में नहीं होते। सेम अगर एक आईआईटी में होता और एक नॉर्मल प्राइवेट कॉलेज में होता तब मैं बात आपकी मान लेता, लेकिन जब दोनों सेम प्राइवेट कॉलेज से हैं, दोनों बच्चे सेम क्लास से हैं, सेम बेंचेस में बैठे हुए हैं, तब ऐसा हो रहा है। तब नहीं, मैं मानूंगा कि भाई उनका कैलिबर डिफरेंट है। दे हैव सेम कैलिबर। ओके, तो क्या डिफरेंस आ रहा है, फिर प्रॉब्लम क्या आ रही है, फिर क्या डिफरेंस आ रहा है इन दोनों में? लेट मी टेल यू दैट ऑल्सो व्हाट इज द डिफरेंस। देयर इज ओनली वन डिफरेंस बिटवीन दीज टू स्टूडेंट्स। द डिफरेंस इज ओनली वन डिफरेंस, कंसिस्टेंसी। दिस इज द ओनली डिफरेंस। कौन कितना लंबा तक जाता है सिर्फ यही मैटर कर रहा है। मैं पिछले 10 साल से देख के बता रहा हूं आपको, एक वर्ड के अंदर यही डिफरेंस है, कोई डिफरेंस नहीं है। कोई आईआईटी का बच्चा द्वारा गेट का एग्जाम नहीं देता है, द्वारा आईआईटी में जाना नहीं चाहता है। कौन दे रहे हैं? जो प्राइवेट कॉलेज में है वही दे रहे हैं, बस वो ही एग्जाम दे रहे हैं, क्योंकि उन्हें अपनी लाइफ चेंज करनी है। दे वॉन्ट टू टेक वन मोर चांस टू चेंज देयर लाइफ। ओके, तो ये तो मत बोलना कि भाई उसमें कैलिबर ज्यादा है, इसमें कैलिबर कम है, ये तो मत, बिल्कुल मत बोलना। सेम क्लासेस से हैं, सेम बेंच पे बैठे हुए हैं। द ओनली डिफरेंस इज हाउ मच इज वन इज कंसिस्टेंट इन देयर स्टडी। और यही सबसे बड़ा चैलेंज भी है। ये बोलना आसान है कंसिस्टेंसी, पर इसको लेके आना वन ऑफ द टफेस्ट टास्क ऑल्सो। शुरू में स्टार्टिंग के 1 मंथ अगर आपने बना ली कंसिस्टेंसी, तब धीरे धीरे आपकी बन जाएगी। और ये कंसिस्टेंसी ऐसी है, ये खाली गेट में नहीं काम करती, किसी भी फील्ड में चले जाओगे आप वहीं पे काम करेगी। अगर आप कॉम्पिटिटिव प्रोग्रामर हो, प्रोडक्ट बेस्ड कंपनीज के लिए तैयारी कर रहे हो, कॉम्पिटिटिव प्रोग्रामर हो, फिर कंसिस्टेंसी चाहिए। किसी भी एग्जाम में चले जाना, यही यही चाहिए अपने को। यही पे यही मैंने यहाँ पे नोटिस किया, सेम क्लास से बच्चे आ रहे हैं। ओके फाइन, हम शायद डाइवर्ट भी हो रहे हैं। टफ नहीं है, टफ नहीं है। टफ टफ एक चीज तब तक है जब तक आपको नहीं पता है। जब आपको पता लग गई वही चीज आसान हो जाएगी, बस इतना डिफरेंस है। टफ नहीं है, ये वर्ड आप मत यूज करिए। मैं बता रहा हूँ टफ तब तक है जब तक आपको पता नहीं है। जब आपको पता लग गया ना, तो वो टफ नहीं है। बस जब तक नहीं पता है तब तक टफ है। ओके, so let's jump back to the questions now. Fine. Answer is A and D over here. Answer is A and D over here. Okay, let me try at my end. ये लूप तो अपने को पता लग रहा है, ये तो एन टाइम जा रहा है ना, ये तो अपने को पता लग रहा है। दोनों को कंपेयर करना है, अपने को देखना है कि दोनों को कंपेयर करना है, F1 को और F2 को। तो F2 जो है ना, जो दूसरा फंक्शन है, ये तो एन टाइम एग्जीक्यूट हो रहा है। फाइन, ये वाला देखते हैं। इसमें एक तो ये आउटर लूप है, एक ये इनर लूप है। फाइन, इनर लूप हमारी एन टाइम एग्जीक्यूट हो रही है, ये तो यहाँ दिख रहा है अपने को। और लेकिन पहले ओके ओके ओके, दिस इनर लूप विल एग्जीक्यूट एन टाइम फर्स्ट टाइम। आफ्टर दैट एन की वैल्यू चेंज हो रही है, देखो एन की वैल्यू हाफ हो गई। तो जो नेक्स्ट टाइम जब हम इस वाइल लूप में जाएंगे, तो एन की वैल्यू कितनी होगी? n/2। तो नेक्स्ट टाइम ये इंटरनल लूप कितने टाइम एग्जीक्यूट होगी? n/2 टाइम। और फिर हाफ हो जाएगी, हाफ का भी हाफ, n/2 अगेन डिवाइड बाय 2। दिस इज एक्चुअली n/2 तो फिर ये लूप कितने टाइम एग्जीक्यूट होगी? n/2 so on, n/2 and so on, n/2 you can say some k। ओके, तो एक सीरीज बन गई। तो n कॉमन ले लेते हैं यहाँ पे, 1 + 1/2, 1/2 1/2 ठीक है। और एक्चुअली दिस इज डिक्रीजिंग जीपी सीरीज, डिक्रीजिंग जीपी सीरीज। ओके, तो if you will check out this is a decreasing gp series, the sum of this series will be maximum 1। okay, that will be maximum, okay, maximum I can say 1 point something you can say, or maximum 2 you can say। 1 is from here and this value will be maximum 1। आप यहाँ पे देख भी सकते हो, देखो यहाँ पे 0.5 मिलेगा, ये देखो यहाँ पे 0.0 समथिंग मिलेगा, फिर 0.00, फिर 0.000, 0.000 सम वैल्यू विल बी देयर। ओके, लेट्स पुट 5। तो आप इन सबको ऐड भी करोगे ना, तब भी ये 1 तक नहीं पहुंचेगा। कितने भी टर्म ले लो इसके को, इनफाइनाइट भी ले जाओगे ना, तब भी ये टोटल सम होके ना 1 नहीं आएगा। दिस इज डिक्रीजिंग जीपी सीरीज। ओके, तो 1 + 1 2 भी हो गया, तो कितना हो गया टाइम यहाँ पे? 2n, दैट इज n ओनली। सो तो ये फंक्शन भी n टाइम ले रहा है और ये फंक्शन भी n टाइम ले रहा है। तो देखते हैं क्या रिलेशन है। दोनों थीटा से रिप्रेजेंट कर सकते हैं, बिल्कुल कर सकते हैं, थीटा तो इक्वल ही शो करता है। स्मॉल ओ में स्मॉल ओ से नहीं, स्मॉल ओ तो F2 फंक्शनली ग्रेटर होना चाहिए। देखो ये 2n है, ये 100n है, तो मे बी आप बोलो ये 100n है, ये 2n है, नहीं, कांस्टेंट फैक्टर तो हमें रिमूव कर देना है, ठीक है। उसके बाद आपको फंक्शनली चेक करना है, क्या फंक्शनली ग्रेटर है। अगर ये स्क्वायर होता तब तब स्ट्रिक्टली ग्रेटर था, लेकिन अभी तो एन फंक्शनली इक्वल है, तो ये दिस इज रॉन्ग, बी इज रॉन्ग, और ये भी रॉन्ग होगा क्योंकि इक्वल है वो बिल्कुल। और स्मॉल ओमेगा जो है ना वो बोलता है लेफ्ट हैंड साइड शुड बी ग्रेटर देन राइट हैंड साइड, स्ट्रिक्टली ग्रेटर। और बिग ओ, बिग ओ हम ले सकते हैं क्योंकि बिग ओ ना इक्वल भी शो करता है। बिग ओ लेफ्ट हैंड साइड इज लेस देन इक्वल टू राइट हैंड साइड होता है ना, तो इक्वल भी वहां पे रहता है हमारे पास, तो बिग ओ हम ले सकते हैं। तो ए एंड डी कैन बी द राइट आंसर। ओके, सो आई होप यू अंडरस्टैंड दिस, ए एंड डी इज द राइट आंसर। कंपाइलर, compiler, do you understand how we are getting n over here? n भी डिक्रीजिंग हो रहा है, n को तो हमने कॉमन ले लिया बाहर। देखो यहाँ पे n वैल्यू थी, ओके, आप इसको डिक्रीज कर रहे हो, ठीक है, इस वैल्यू को आप डिक्रीज कर रहे हो, डिक्रीज कर रहे हो, डिक्रीज कर रहे हो, ओके, इसको वैल्यू को, लेकिन ये n तो आपके पास है ना, एक n है ना आपके पास, ये पहली बात तो ये। दूसरी बात, इसको सिंप्लीफाई करने के लिए आप इसको हम ऐसा लिख सकते हैं, लिख सकते हैं बिल्कुल, n को कॉमन ले सकते हैं। अगर हमने n को कॉमन ले लिया, n बाहर है हमारा, मल्टीप्लाई में है इस सीरीज के, और ये सीरीज आप देखोगे दिस इज डिक्रीजिंग सीरीज, डिक्रीजिंग जीपी सीरीज। अगर इसका सम भी करेंगे ना आप, यू चेक आउट ऑन द इंटरनेट अबाउट डिक्रीजिंग जीपी सीरीज मोर डिटेल। मैं इंट्यूशन से बता रहा हूँ अभी खाली, आई एम नॉट गोइंग इन द प्रूफ, बट इंट्यूशन से भी बिल्कुल इजी है समझना अपने लिए। अगर आप देखो इसको सम भी करेंगे ना, तो नीचे वाला डेनोमिनेटर जो है ना इसका, आप देखो ये बड़ा होता जा रहा है, ऊपर वन ही है, नीचे डेनोमिनेटर बड़ा होता जा रहा है, तो डेफिनेटली ये वैल्यू स्मॉल होती चली जाएगी, स्मॉल होती चली जाएगी, ये वैल्यू स्मॉल होती चली जाएगी। तो अगर आप इनको सम भी करोगे ना, इन इस वाली पार्ट का सम, इस वाले पार्ट का सम वन भी नहीं पहुंचेगा, वन तक भी नहीं पहुंचेगा, क्योंकि आप इसको ऐसे कुछ ऐड कर रहे हो, ये वन तक भी नहीं पहुंचेगा, ठीक है। और जब ये वन, लेट्स सपोज हमने अपर बाउंड ले लिया वन, वन प्लस वन टू, तो दिस विल बी टू एन ओनली, ओके, ये मल्टीप्लाई में थे हमारा, वन प्लस वन टू, टू एन, ओके। सो दिस कोड विल टेक एन टाइम टू एग्जीक्यूट, आई कैन से, ओके। जो वाइल लूप है ना, ओके, एक बार और हम करते हैं इसको। देखो ये हम ये देख रहे हैं, इसने बोला है कि ये जो स्टेटमेंट है ना कितने टाइम एग्जीक्यूट हो रही है, ये वाली देखते हैं कितने टाइम एग्जीक्यूट हो रही है। पहली बार आए हम अंदर, तो ये जो लूप है ना एन टाइम एग्जीक्यूट हुई, ये तो अपने को पता है एन टाइम ही हो रही है। फिर ना एन की वैल्यू हाफ हो गई, ये लूप से बाहर आए हम, इस लूप से बाहर आने के बाद अभी वाइल लूप में है, वाइल लूप यहाँ तक है, ये एन की वैल्यू हाफ हो गई, एन की वैल्यू हाफ है, तो ये जो इंटरनल लूप है ना वो एन बाई टू ही टाइम तो चलेगी, क्योंकि एन की वैल्यू हाफ हो गई है। तो इंटरनल लूप आपने चलाई एन बाई टू टाइम, वाइल लूप चल रही है, ये जो चल रहा है ना ये वाइल लूप ही चल रही है। ये एक बार हम, ये इंटरनल लूप है, ये जो इंटरनल लूप है, ये इंटरनल लूप है, और ये जो चल रहा है ये वाइल लूप में चल रहा है। ये कब तक चल रहा है, जब तक हमारा एन वन से ग्रेटर है। आई डोंट नो वो कब तक चलेगा, मैंने लिख दिया टू पावर के समथिंग, ओके। तो ये ऐसे वन टाइम, टू टाइम, थ्री टाइम, फोर टाइम, ये वाइल लूप एग्जीक्यूट हो रहा है। और ये जो एग्जीक्यूट हो रहा है, ये कौन एग्जीक्यूट हो रहा है, इंटरनल लूप, ओके। तो फिर हमने इसको एडअप, हमने देखा अभी हर वाइल लूप के अंदर कितने टाइम हमने इस स्टेटमेंट को एग्जीक्यूट किया, पहले एन टाइम किया, फिर एन बाई टू टाइम, फिर एन बाई टू टू स्क्वेयर एंड सो ऑन। जब हमने इसको सॉल्व किया तो अपने को एन मिल गया, और यहां से भी एन मिल रहा है, दोनों साइड से एन मिल रहा है, तो अपने को ए एंड डी इज द राइट आंसर, ओके, फाइन, ओके। ट्राई दिस वन, Or maybe okay, let's move on now. You can try this at home. You can take the snapshot of this question. You can try this at home, and you can write the answer in the comment section. Please come and write this in the comment section. Okay, and if you like this session till now, please give a thumbs up. Please give a thumbs up so that this can reach to maximum students. Okay, only your thumbs up and your comments actually make it able to reach to maximum students. Okay, otherwise this information will just end up here itself. So we feel motivated when our sessions go to maximum students. So please keep sharing, uh, keep commenting, and keep giving the thumbs up, please. Okay, fine. You can try this at home. People are replying answer. Okay, D is the right answer over here. Okay, don't worry, you can try it at home. Okay, and this is gate 2003. You can take the snapshot. You can try this at home. Answer is A over here. Okay, and this is 2001. Answer is B over here. Don't need to worry, it's okay. You can, this is just for practice again. D, and answer 2021. You can solve all the question. You can solve all the questions. You just need just give your time, keep practicing, study from the place which is really helping you to solve the gate questions, because these are the questions, this is the level you need to achieve. If you are not able to solve these questions, then that course have some problem. That course have some problem. Believe me, that is just wasting your time and money. D is the right answer over here. And okay, this is the last question. The answer is C. Fine, it's okay. You can find out the lots of question on Geeks websites. Also, all the PYQs are there. You can practice over there. Topic wise, you can find out. Okay, fine. Let's talk about the now sorting and searching techniques. Before moving that, okay, can you tell me what is the function of this code? Can you tell me what is the function of this code? What is the function of this code? What this code is doing? Yes, we are performing linear search here. We are performing linear. We are searching an element X inside an array. The array size is n. We are searching that one by one in the array from I0 to n minus 1. We are checking each element, comparing with this X. If we find the element, we return true. If we don't find the element after coming out of this loop, we return false. So we are comparing with each element one by one, one by one. First, we compare with 0th element, then 1th element, then 2th element, and so on up to 0 to n minus 1th element we compare. Okay, so we are performing linear search. Okay, and when we perform linear search, the time complexity actually reaches to order of n. Order of n. One by one we are comparing with n elements. So time complexity in the worst case, that will be n. Okay, although extra space we are not taking anything over here. Auxiliary space is constant. See, this is the input space. They provide us the array. This is the input space. Input space complexity is order of n. But to solve this problem, we just use one variable, one extra variable. Okay, maybe you can say this is also another two variables you have used. So we take three variables. Three variables, you can say that. Okay, so three variables is constant. 3 into 4 bytes. 12 bytes we use extra, so that is constant. So extra space taken is constant over here. Okay, total space complexity, you can say order of n. Total space complexity, input space plus auxiliary space. Fine, okay, just adding more information. Okay, here is now one interview question asked in after you crack the gate exam. You need to clear the interview also. I'm sharing one interview question. This is the interview question. Can you answer this? Can you answer this interview question, IIT interview question? Please reply in the chat box. Try to answer this question. Please try to answer this question. Many people fail to answer this question. Many people fails to answer this question. Order of one is not right answer. Order of one is not right answer. Order of one is not right answer. A question is not visible. Mm, this is unsorted array. Yes. Okay. There is a. Mm, okay. So let me read the question. What will be the best case time complexity to find the minimum element in an unsorted 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 array? After in an unsorted array. So order of one is not the right answer. The array is not sorted. Okay, that is order of n. ये ओके यहाँ पर हम क्या कर रहे हैं, क्या क्या पूछ रहा है, ये पूछ रहा है बेस्ट केस टाइम कॉम्प्लेक्सिटी क्या है मिनिमम एलिमेंट फाइंड आउट करने की एक अनसॉर्टेड एरे के अंदर। ठीक है, चलो मैं एक स्टोरी बताता हूँ आपको, उससे रिलेट करते हैं अपने को। देयर इज अ क्लास, अपने पास एक क्लास है, ये कुछ बच्चे बैठे हुए हैं, ठीक है। मेरे को पता करना है इस क्लास में मिनिमम एज किसकी है, किस बच्चे की सबसे मिनिमम एज है। देन आई आस्क टू द फर्स्ट स्टूडेंट व्हाट इज योर एज, ही सेज दैट माय एज इज 20 ईयर। I asked to the second one, he says that my age is 21. So I keep this way, I keep asking to everyone. I'm asking to everyone, okay? I'm asking to everyone. I ask to n minus 1 student, okay? I do not ask to the last student. I do not ask to this last student. Can I give the right answer right now? Can I tell the minimum age? What will be the minimum age? I just asked to the n minus 1 students. मैंने सिर्फ n माइनस 1 स्टूडेंट से पूछा है, एक स्टूडेंट से नहीं पूछा, सबसे पूछ लिया, खाली एक बच्चे से नहीं पूछा, सबसे उनकी एज पूछी और खाली एक बच्चे से नहीं पूछा मैंने। तो क्या मैं राइट आंसर दे सकता हूँ क्या कि भी किसकी मिनिमम एज है क्लास में? क्या मैं ये राइट आंसर दे सकता हूँ क्या, या अभी भी मैं राइट आंसर देयर मे बी अ प्रॉब्लम इन दैट? No, I cannot give the right answer. I need to ask to the last student also. Until unless I will not ask to the last student also, I'm not sure if I know the minimum age of a student in class. I need to ask to the last student also. Might be last student says that she is only 16-year-olds. Yes, she can say that she is a girl. She can say that I'm only 16-year-old. We need to believe also. So until unless I'm not covering each and every element, I cannot say that, okay, which is having the minimum age or which is the minimum element. Okay, so I need to go through all the elements. Okay, either that is best case or worst case. So the complexity will be order of n here. Fine. Let's talk about a little bit binary search. That is another method to search an element. So how to search using binary search? Binary search can be applied on sorted array. So whenever we are searching an element, okay, let me tell you one thing. पहले तो ये चीज आप अपने दिमाग से थोड़ा सा निकाल देंगे तो सही रहेगा। बाइनरी सर्च, ये हमारे माइंड में आता है कि बाइनरी सर्च जब हम अप्लाई करते हैं तो एरे सॉर्टेड होना चाहिए, एरे सॉर्टेड होना चाहिए, तो ऐसा नहीं है। बाइनरी सर्च हम अगर एरे सॉर्टेड भी नहीं है तब भी अप्लाई कर सकते हैं, ठीक है। ये आप देयर आर मैनी प्रॉब्लम लाइक finding next maximum element, finding next minimum element. There are many problems over the internet, programming problems. You will find, you can check out those, and you will find out that binary search can also be applied on unsorted array. Okay, right now in this context, okay, right now, uh, ओके आई एम टेलिंग यू बाइनरी सर्च कर वी आर अप्लाइंग ऑन सॉर्टेड एरे, क्योंकि अपने को एक एलिमेंट फाइंड आउट करना है। प्रॉब्लम क्या है, प्रॉब्लम क्या है, एलिमेंट फाइंड आउट करना है, उसके लिए बाइनरी सर्च एलिमेंट सॉर्टेड होने चाहिए। लेकिन अलग प्रॉब्लम के लिए भी हम बाइनरी सर्च अप्लाई कर सकते हैं, और उसमें यू डू नॉट नीड टू बी हैव एरे टू बी सॉर्टेड, यू डू नॉट नीड टू बी हैव एरे एज सॉर्टेड। ओके, like next maximum element you can check out on the Google later on. Okay, so right now, okay, let's keep it easy. So we can apply the binary search to find out one element on sorted array, only on sorted array. If you're finding the element for this problem, finding the element, this problem, array should be sorted, that is sure. Okay, fine. So how to apply? Very easy. This array is sorted 3, 5, 9, 14, 29, 40, 52. What we need to do, we will just go to the middle element. Let's suppose I'm searching for 9. So I will compare 9 with 14. Because 9 is smaller than 14, I know that 9 will be at the left hand side. क्योंकि एरे सॉर्टेड है तो अपने को, मेरे को पता है ये वाले एलिमेंट तो बड़े ही होंगे 14 से, और 9 तो है, 9 जो है ना वो छोटा है 14 से, तो अपने को लेफ्ट साइड में ही मिलने वाला है वो, ठीक है। तो आधे एलिमेंट हमने सीधे एक साथ हमने चेक करके भी नहीं देखा उन्हें, ठीक है। तो फिर इधर आगे लेफ्ट हाफ में अगेन वी कंपेयर विद द मिडल वन, this time we find out that 9 is greater than 5, then we will check in the right hand side, and this time we find out our element. So simply the idea is that find out the middle element, and compare that element with our element which we want, which we are searching for. If that is smaller, then search in the left hand side, otherwise search in the right hand side. Up again, applying the same procedure means again find the middle, compare with the middle. If smaller, go to the left, greater, come to the right. And how to find the middle? Simply add the low plus high divided by 2. Like for example, if I want to find the middle over here, this is high, this is low index, so low plus high index divided by 2, that's it. 6 by 2, that is 3. So you can see middle element is at the third location. Fine, that's it. This is binary search, that's it. Okay, again this is one another interview question ask in the, this is actually 2023 itself, ask in IIT Bombay. Can you answer this question? Can you answer this question? This is related to this topic, that's why I added over here. Get aspirant, here in this case we are taking floor value, we are not taking seal value, we are taking floor value. Integer takes the floor value. Yes, Aryan, you are right. The complexity for that, if we are, see, we in binary search we divide the array in two parts. They are saying that what about if we divide it in three parts? Yes, we can divide the array in three parts. Like this, I can, maybe I can find, earlier I was finding the middle element, I can find out this element and this element, and comparing with these two. Based upon these two, I will search either here or here or here. At one place I will search. So earlier the time complexity was log n base 2. Now that will be log n base 3. Because I'm not searching in two parts. I'm searching in one part only now. Any of these one part. Okay. So the complexity will be log n base 3. Okay, one more question I can add in this. The question can be, okay, here you are comparing with one element in one go. Here you are comparing with two elements. Okay, to take the decision, okay, whether to search this in part 1, part 2, or part 3. You're comparing with two elements. So okay, on average, which will take more number of comparison? Means uh, part 1, this solution 1, or solution 2, which will take more number of comparisons. So I'm comparing, making two comparison here, I'm making one comparison here. Okay, on average we can say that this will take more number of comparisons. Okay, although it's not always true, it's not always true. Okay, there might be cases that this is the number of comparisons can be less here. Why? Because here you are not dividing, here dividing in two parts, 50-50. Here you are dividing in 33, 33, 33 almost. Okay, so your next time you have very small size as compared to 50. Okay, but on average if you will calculate, then okay, this will take more number of comparisons. Still this will take more number of comparisons. Okay, although this is looking like that, okay, this is reducing the size more, then we will converge. We have might we use the word converge, means our algorithm will end faster here. Yes, our algorithm will end faster here, so the comparisons will reduce. Yes, but still that will be on average greater than this one. Okay, fine. Again, one more question if you want to try. This is again interview IIT question. This is again from interview IIT question. And this particular question is also uh, people ask in product based company also. Same question I have seen asked in the product based company, and the same question is asked in IIT. Actually, the people I have seen that, okay, who are going to product based company, they have many people are there who are clear the gate exam. After clearing the gate exam, they are getting placed in good product based companies, and then they are using these questions to ask to the applicants. Actually, okay, they're using these questions, that gate question itself. Okay, can you answer this question? What is the time complexity to determine if the integer appear more than n by 2 times in an sorted array of an integer? Okay, let me explain what this question is first. So we are given n sorted array. Fine, let me make a sorted array and of n elements. Okay, this is my sorted array of, let's suppose, n elements. So maybe 0, 1, 2, 3, 4, 5, 6. We have 8 elements, 0 to 7. N value is 8. We need to find out if there is any integer in this array which is appearing more than n by 2 times. Okay, maybe I can make an integer like 10 is here, 20, 30, or maybe 30, 30, 30, 30, and maybe 40. So here in this array, 30 is repeating more than n by 2 times. Okay, so how much time you will take to find out that if somebody provide you a array, and can you how much, in how much time, best case complexity we are talking about, optimal solution we are talking about, how much minimum time you can find out that, okay, uh, some elements is repeating more than n by 2 times. Okay, are you understanding the question? So because this question is asked in IIT interviews, and the same question is used by these product based companies, so one thing is sure, the answer is not order of one. Answer is not order of one, Shubham. No, Imran. Answer is not order of one. Okay, what about this one? So ho- means how you are coming with order of one. Okay, let me take another example. 10, 20, 30, 40. Okay, let me 40, 40, 50, 60. Let's suppose this example. So in this, maybe if you are giving order of one answer, maybe I don't know, maybe thinking that uh, how you will find out, okay, if the element is repeating n by 2 times. Maybe one solution to give order of one time complexity is, with the help of this hint we can do is that, okay, if the number is repeating n by 2 times, if the number is repeating n by 2 times, then the number will definitely will be at the middle. This is sure. Yes, this is sure. If the number, if any number is repeating n by 2 times, okay, then that number will definitely be at the middle, like for at the fourth place, if is the middle of, okay, and then I can say that, okay, number will, okay, let me make it more middle. Let me take it odd numbers. So here we can see that 4 is the middle. Okay, so number will definitely will be at the middle if number is repeating n by 2 times. Okay, so we can directly go to the middle element and we can tell, okay, 30 is the answer. But we need to reply yes or no. For this problem, we need to reply no also. What about if this happens? You go to the middle in constant time and you say that 40 is the number which is repeating n by 2 times. 40 is not repeating n by 2 times. 40 is only 3 times here. 40 is not more than 4 here. 40 is not more than 4 here. 40 is 3 here. So you need to reply no also if that number do not exist. For that you need to check. For that you need to check. Imran, yes. So it's not compulsory that, okay, the middle element will be the solution, because that might not be the might there might not be the any integer in our array which is repeating n by 2 times. Okay, we need to reply yes or no. In this case I will reply no. In this case I will reply yes. There is a number. Yes, there is an integer in my array which is repeating n by 2 times or more than that. There is, but here for this input I will reply no. I need to reply no, and I cannot reply no in constant time. I need to verify. I need to verify. So what we can do? So what we can do? Yes, first thing is you are right that we need to come to the one thing is sure. If there is such number, then that will definitely will be at the middle. So we are assuming that, okay, let's suppose 30 is the number which is repeating n by 2 times. Then what we will do? Now this array is sorted. They are saying that the array is sorted. So we can apply the binary search here and we can find out the left end of 30. Okay, and we can find out, we can again apply the binary search here also, and we can find out the right end, and then we can find out, okay, how many elements are between 6 to 2. So we can see that, okay, 6 minus 2 plus 1 we need to do, so that will be 5 elements are here. This index minus this index plus 1, so 5 elements. Yes, now we can say that, okay, there is a number which is repeating more than n by 2 times. But in this case, when we will apply binary search, we will find the index 3 here and 5 here, and we will calculate 3 minus 5 plus 1. That will be actually 3 only. Okay, and 3 is not more than n by 2, and is actually 9 now. Okay, so this is not more than 4. Okay, this is not more than 4. So yes, we can reply no, but we need to apply the binary search. We can apply the binary search over here to find out the left index at which this number exists, and to find the right index at this number exists. Which number we are looking for? Which is at the middle. Why we are picking this number? Because we know that if there is such number, if there is such number which is repeating n by 2 times, more than n by 2 times, that will definitely will be at the middle. that will definitely will be at the middle. Okay, I hope you get the idea. So this will take log n time here, log n time here, you can say 2 log n time, so that is log n only, that is log n time. So this problem will take log n time to solve, this problem will take log n time to solve it. Okay, any doubt in this you can ask me, otherwise you can read this statement. There are some sorting algorithms which can solve the problem in order of n time. Can you tell me, can anybody tell me which sorting algorithm can solve the array elements, can sort the array elements in order of n time? Can you people tell me, anybody? Can you tell me which, in the worst case I'm talking sorting? Now we come to the sorting, we are not we are searching is done, searching is done. Okay, you can try the questions. Let's talk about the sorting first. So I will cover the sorting. Okay, I will give you the concepts, then you can apply the to solve the question. You can easily solve the question after this. Counting sort, yes Shubham, you are right. Bucket sort, yes Aryan, you are right. Radix sort, yes you are right. So let's see different type of sorting algorithms. There are two type of sorting algorithms. One is comparison based, and another one is non comparison based. Okay, in comparison based, like a bubble sort, selection sort, okay, insertion sort, merge sort, quick sort, heap sort, these are popular one. Okay, and in non comparison, like you already tell me, counting sort, radix sort, and bucket sort. Let me write the name: bubble, selection sort, insertion sort, merge sort, quick sort, heap sort. So I'm making a table here which is covering many gate questions also. Like I'm telling you the best case, average case, and worst case complexity of these algorithms. So I will not cover complete, but I will cover some of them. I will left some of them which is most important. I will leave them for you people. I will cover, but first you need to answer. Okay, first you need to answer. Uh, okay, you need to tell me what is the best case complexity of bubble sort. Average case is n square. Worst case is also, I'm just writing directly, I'm not writing this asymptotic notation, I'm directly writing n square. Selection sort, best case is n square. Please let me know the best case complexity of bubble sort. Keep replying please. Best case complexity of bubble sort. I'm leaving some of the spaces, please fill, please help me to fill them. Here this is n square, n square. Insertion sort in best case, please tell me. Insertion sort in best case. I'm leaving the most important one which are asked in the gate exam. Somehow related questions are asked in the gate exam. Here this is n log n, this is n log n, this is also n log n. All the cases merge sort n log n. Quick sort, best case n log n, average case n log n. Please tell me worst case complexity of quick sort. Okay, heap sort, best case n log n, average case n log n, and worst case n log n. Three places, please help me to fill up. Okay, gate aspirant says that insertion sort best case complexity is order of n. Yes, you are right. Order of n, yes. And quick sort is n square, yes. So let me write here n square. And what about the bubble sort? Best case. So that is n. Yes, you are right. That is Let me write it other way. Here, okay, more accurately, I can say this is n, okay. But if somebody is saying n square, that is also not making false statement. If somebody is saying n square, that is also making false statement. Okay, Avinash, I'm coming to your question. Let me let me finish this table first. Then I will come to your question. Okay, is that fine? Okay, so what I'm telling you is that bubble sort. Worst case, if somebody asks you what is the best case complexity of bubble sort, you can reply in this manner. That will be much better. You can reply that, okay, the worst case complexity of bubble sort is n square. The worst case complexity of, the best case complexity of bubble sort is n square. But we can improve it. We can improve it to order of n. We can improve it to order of n by making little bit modification in the bubble sort. We can improve the complexity to order of n. This is the best answer. Okay, rather than just speaking directly order of n, this is the right answer. That, okay, the bubble sort best case complexity is order of n square, but we actually you can check out the optimized code, that is where we use the flag. Okay, and by using a flag, we come out of the outer loop. Okay, we do not execute. After one time executing the loop, we come out if the array is already sorted. Okay, we check that, okay, if array is already sorted, we do not execute the complete algorithm. We just come out. In that case, that take order of n time. So if array is completely sorted, then bubble sort take order of n time. We can improve it to n time. Okay, okay, fine. There is one question from Avinash. Let me read this first. Sir, in one of the previous question, to find if the element more than n by 2 time, we can use comparison. If the middle element is equal to the first or last element of the array, if equal, then it's true. That can be one case, Avinash. Avinash, that can be one case. That, okay, if all the array have the same elements, if all the array have the same elements, okay, if all the array have the same elements, then only this condition will be satisfied. But even though we are only checking for n by 2 elements, okay, we are only checking for n by 2 elements. So in that case, uh, first element and last element may not be same as the middle element, but still there can be an element which is repeating more than n by 2 times. Yes, first and last elements are not matching with the middle element, but still there can be element which is repeating more than n by 2 times. Okay, fine. So, okay, non-comparison based sorting algorithms take in all the cases, best case, average case, worst case, they take order of n time only. Okay, okay. Let me ask you some questions, some interview questions, uh, which can be asked in IIT. Okay, and which is related to the gate questions also, and which is asked in actually product based companies also. Okay, from this slide, let me ask some questions. First question is that here we can see that non comparison based sorting algorithms take order of n time in all the cases. Okay, and these people, comparison based sorting algorithms, are, see, you can see in the worst case, see the complexity, the minimum time complexity in the worst case for any algorithm, you can check out, minimum is n log n. Here worst case complexity is n. But let me tell you one thing, in most of the applications, in real life most of the applications, we used comparison based sorting algorithm. We do not use non comparison based sorting algorithm. We use them only in special scenarios. We do not use comparison, we use comparison based sorting algorithm. Okay, now is my question. My question is the complexity of comparison based sorting algorithm is lying between, okay, from n log n to n square, even that is leading to n square, and some are taking n log n. Okay, in average case also you can see, in best case only except this bubble sort and insertion, every other is taking n log n and n square. So why we are using comparison based sorting algorithm, why not non comparison? They are taking order of n time only, they are taking only order of n time in all the cases. These people are taking n square, n log n. Still I'm saying that comparison based sorting algorithms are mostly used in real life applications. Okay, we do not use non comparison. Why this is happening? Can anybody tell me? So this is one question. Okay, why we are not using non-comparison based sorting algorithm? Why we are using comparison based, even though they are taking more time? You can see in the table itself, they are taking more time. Okay, okay. Maybe you are writing someone. Maybe writing takes time. Also, that's it. That is also there. Okay, fine. Otherwise, let me tell you. The reason is that non-comparison based sorting algorithms have some limitations. These have some limitations. Okay, they have some. They actually, it's like they bound the user. Okay, just okay. Let me take an example. Let's suppose I'm asking to the counting sort. Hey, counting sort, can you please sort some number for me? I ask him, can you please sort some number for me? Counting sort reply immediately. He say that, okay, I will sort the number. I will sort your number in order of n time, but you plus make first me make sure that you will not give me large numbers to sort. You will not give me large number. You will not give me large number. Just like if just like if I ask him, can you please sort these two numbers, 1 lakh, there is a one number 1 lakh, and there is another number 2 lakh. These two number, I give him two number to sort. Can you please sort these two numbers? I ask to the counting sort. Counting sort say that I already asked you to don't give me the large numbers. If still you want me to sort this number, I will sort, but I will consume your complete ram. I will consume your complete ram. Then I will say, please go to hell. To sort two numbers, you will consume my whole ram. Actually, counting sort have limitation. Like he cannot handle the large numbers. To handle the large numbers, he need more memory. Okay, so he's bounding me. The moment you start bounding the user, the moment industry says that the moment you start bounding the user, you are degrading the quality. We cannot bound the user. You will not like a software which is bounding you. You will always like a software which is have very less restrictions. So if you want to sort the numbers and he is asking don't give this type of number, don't give that type of number, you will say please go to hell. You will delete that app and you will install some other app. So these algorithms have limitations. Static sort is saying that if you want me to sort the number, tell me how many digits you have in the number. How many digits you have. So they have limitations. They are bounding you. They are already asking how many digit number you will give to me. What is the size of the element you are giving to me? So these type of questions they are asking. Otherwise, if you still provide them those numbers, they will behave very worst. Like they will consume the complete RAM. Okay, so that's why these are not used in real life, except some exceptional cases where we can apply them, where we know that okay, we don't have big numbers to sort. Although let me tell you, counting sort is famously used for string problems. In string solving the string problems, we use counting sort. The people who know the, I don't know if you know the unordered set. in C++ or has set in Java inbuilt library functions. They are working on the principle of counting sort only. They're working on the principle of counting sort. So if we want to sort the string, okay, to sort those, counting sort is one of the best algorithm. Why? Because number of alphabets are 26 only. They are fixed. They are fixed. They are very small number. You know that maximum you can go from up to 26. Okay, so their counting sort will be the best algorithm. And many of the problem, if you will see over the internet, then you will see that string problems they will ask you to solve in order of n time. And actually at the back end you need to apply counting sort. People are solving them using like unordered set and hash set. Okay, they are also using actually the concept of counting sort at the back end. Even you do not need that library function, you can solve the problem in counting sort. People ask, without using these functions, can you solve directly? Yes, then you can use the counting sort. So for special scenario where the size is small, where you are satisfying the conditions, it's better to use these algorithms because they are taking less time. But in real life actually we cannot bound the user, that's why we use the comparison based. Fine. So these are the different type of algorithms we have.